Yeah.
Hello, welcome, Coleman. Today is February 12th, 2025. Welcome to the Propeller Live Forum. How's everybody? Good. Okay.
Thanks.
Feel free to unmute yourself. Okay, so today, at the request of a customer of ours and others, Eric will talk about the latest in FlepProp, and I think there's a focus in there, the use of spin and C together, which should be interesting. Hey, Eric, good to see you. So this was actually scheduled for next month, but Johnny Mac was going to talk this month, but when Johnny Mac realized this month was really here and it was this month, he changed his plan, and Eric Smith said we'll do it
Well,
this
Ken,
month.
I think John's prepared to show the layer plot thing, or what do we call it, layer crop
Okay.
thing in the plot window.
Oh, cool. Yeah, and that's different than what he has planned though. Yeah, he's also doing a presentation about the project he's working on, so we can have him do that today also. And then you're going to talk about compiler updates
Sure, yeah.
that you're making. And then does anybody else have any other topics or, or support questions or whatever? You could just jump in. There's no formality here. So, or message me or use the chat or whatever. Okay. So while everybody comes in and gets seated, we'll do the housekeeping. Since our last meeting, you may have seen that Microsoft Marco released this binary firmware downloader, which was requested by one of you. So it's a standalone tool so that developers can give their binary files to customers who have their products, and they can update them without seeing the source code and without loading development tools, yada yada. So it's a simple standalone program. You just choose the COM port and your binary file, and then whoosh, away you go.
And I've had customers use both the Windows and the Mac version successfully, so it's working great.
I'm so glad. Happy to hear that. So I put a copy of the link to this in the chat if anybody wants to check it out. And there is a link there to support Marco with the donation. Like all of the stuff, this is free and open source, and he doesn't ask for anything, but we really need to support him to keep encouraging this kind of thing. Also on OBEX, under Chips Tips, there are several new things posted. So Chip has been busy apparently. He might have a ghostwriter for some of these, we have to say, but among the new things, there is the getting started videos from Johnny Mac, all in one place, a 10-part series that we released sometime 2021 maybe, using all kinds of different hardware IO devices, and the objects for these can be found in our forums. And then something else new here that I saw was, I think, this debug plot layer and crop. That's what Chip and John, I think, are working on right now. So that's on obex.parallax.com. And then you may have seen this if you read my spam. We are hosting an event at Parallax. You are all invited. It's a 2-day thing. Friday is open house and education day. It's not uncommon. We'll get a school bus showing up with the teacher, and the kids unloading Parallax, and the public will come, and we'll do manufacturing tours, which people always find interesting. So we'll show you our pick and place line, our through hole assembly line, and how we put stuff in boxes and other very exciting things on Friday. And we'll have all of our robots working too, some big ones, some small ones, things like this that you've seen from me all the time over and over. I have various contraptions that I built through the years. that
Intel has a whole range of new laptop processors coming out.
I'm gonna
But-
mute somebody. There we go. So you can see these things, play with them, and all of our educational robots on the Friday. And then on Saturday, it's the Propeller Developer Day. So we'll switch the tune a little bit and have more developer-based topics. It's very likely we'll have some special guests that day who are traveling from afar, and some Propeller heroes and contributors will be here. So, you know, if you live far away and you want to make the trip, we'd welcome you, and would really like to have you at our office. So on this day, a whole bunch of things will happen, but you can have a table to show off your stuff. You can share it with a screen. We'll have some hardware handouts. We'll have lunch of different kinds, and we'll schedule some talkers, some presentations, and some show and tells. And there might be some cool stuff which you have not seen in person before, but you would like to. Things like this. So help us make this a great event. And of course, Chip will be there, and a long list of other people. So the invite for this tomorrow will be sent out. It'll be an Eventbrite link. You don't have to give any credit card information. It's just a way to get us to know who's coming and how many people we'll have, so we could do some level of planning. But it's free. So I might get a spam off tomorrow to all of you. We'll see how things go. But being that I work at home, usually when I get to the office, there's a lot of stuff to deal with. So it's possible it could be a one-day delay. So who's thinking of coming to Open House or Propeller Day? All right, cool.
At Capital One, we start with apply.
Yes,
Thank
sir.
you.
I'll be there Saturday.
You're going to come join us?
Yes, sir. I will be there on Saturday. I'm making all the plans now.
We'll pick you up at the airport.
Got it. Thank you.
You got it.
I'd love to come, but like you need to figure out some logistics. I don't know. Are hotels in the US even like affordable for someone with like very little money?
I think a hotel in Rockland is probably about $150 a night.
Yeah, that's like the money.
Yeah, it's I admit it's expensive to travel here. And
Possibly unaffordable, which is kind of annoying.
Well, we can work out some things, you know. We don't have any house in Rockland anymore, but I'm 2 hours north. Ken's
2 hours east.
2 hours
Yes.
east. Yeah,
Sleep in Chip's bunk bed.
it'll be a warm time of year.
The nearest airport is Sacramento, but it's probably easier to fly into San Francisco than take the Capitol Corridor Amtrak train, which you could get to via a combination of Bay Area Transit and going under the bay and then getting to Oakland. But yeah, I admit it's an expensive thing to do. We were wondering if you would make it, among others. So we'll see.
Yeah,
how that-
might need some assistance if that's to be a truth.
yeah.
Also, like monitoring the unstable political situation. Let's just call it that.
Yep.
Very interesting things happening.
Yeah. Absolutely. Well, we welcome everybody, and we hope to get good attendance. And you'll see between now and May, I'll be chumming the water, so to speak, with reasons to come to Parallax, setting some hooks on all of you. Yeah, speaking of money, feel free to make a donation to Eric today and his Patreon. So I'm putting a link in the chat. Go grab it and join me in supporting Eric. Eric, are you ready?
Yeah, sure. Anytime.
Cool. Glad you could make it today. I know you had the least amount of planning time too.
Yeah, it may be a little rough, but you know, I hope everyone will forgive me. If it's,
Sorry about
that's all
that,
right.
Eric. I was supposed to be over on the Disney lot today, but then of course an actor didn't like the weather and canceled. So I'm here,
well, stuff happens. I'm
I've
glad you could.
downloaded all your files so I can follow your presentation.
Well, thanks. I'm glad you could make it.
Hey, John, after Eric talks, are you going to share some of your control stuff interface on the debug menu, or are you going to wait till next month?
I can, because Chip and I were just talking about it. So there's a few things to work out, but I'll show you what I've got because I think it's really useful.
Okay, cool. That way we can get some input to you too.
Okay.
Thanks. All right, Eric, all you.
Okay, let me just see if I can share my screen. Can you see that?
Looking good.
Yep. Okay, cool. So yeah, thanks, Ken. I was going to talk about multi-language, especially C and Spin in FlexSpin, FlepProp. So I would like to thank Ken and Parallax for hosting these talks. I think they're always really useful. And also like to thank everyone who supports me on Patreon. It really helps because it lets me buy things like the code signing certificates, which are kind of ridiculously expensive, and Apple developer membership and things like that just make things a little bit smoother. I'd also like to thank my employer, Collabora. They support open source in a lot of different ways, but they also give employees a limited amount of time to work on open source projects like FlexSpin and other things. I do want to emphasize that FlexSpin is my own hobby project, and it's not anything official from Parallax or from Collabora, so the bugs are my own fault, not Ken's and not my employer. But I guess you probably know that. So just going to quickly review FlexSpin and FlepProp. FlexSpin and its cousins, FlexCC and Spin to CPP, they're all command line tools that take PASM or Spin, both 1 and 2, or BASIC or C, and convert it to either P1 or P2 instructions directly, or bytecode, either the P1 ROM bytecode, which Ada contributed the backend for, or a custom bytecode for P2. And the original tool, Spin to CPP, converted Spin into C or C++, way back when that was how everything started. So the FlexSpin command line can be used for many different GUIs, including Maca's wonderful Spin Tools IDE, Stephen's VS Code, and of course my own FlepProp. The compilers are all basically the same, except they have slightly different command line options. Like FlexCC is designed to be like GCC and other C compilers. Spin to CPP is a little bit easier for converting to C code and stuff. But the underlying technology is the same. It's just the command line options that are different. So FlepProp is my IDE designed for use with FlexSpin, and it works on all the platforms, Mac, Linux, Windows. It's kind of a lowest common denominator IDE. It's not as nice as something like VS Code or Spin Tools, but it gets the job done. It's something that anyone can start out with and then maybe upgrade to another IDE. I'm mainly going to be focusing on the features of the compiler and the languages that the compiler supports. So what I'm talking about should apply to any IDE you're using. And no matter which IDE you use, you probably want to get the FlepProp package to get everything, the binaries and the header files and everything you need to compile. And the binaries in the FlepProp package are signed, so the operating system, like Windows, won't complain quite as much at you, although they still make it harder than it should be for you to run programs on your own computer, but that's another topic. So the languages that FlexSpin supports, there's spin 1, the traditional spin for the P1. If you use P2 assembly and don't use any P1 specific hardware features, you can compile spin 1 code on P2. Like for FlexSpin, the difference between spin 1 and spin 2 is mainly syntax rather than which hardware it's targeted for. So if you use, P2 assembly in your DAT section and don't use any P1 keywords, your spin 1 code will work on P2. And similarly, spin 2, you can compile spin 2 code for P1 as long as you use P1 ASM in your DAT section and so on. So as of the recent FlexSpin 7 release, it supports most of the Peanut v48 language that Chip has created. So it has the features like tasks and structs and cool things like that. So overall, I think the spin support's pretty decent. There's still a few things that don't work because the underlying model is quite different. It's a compiler to assembly language. So there are some things that are just not really practical. In particular, FlexSpin doesn't at the moment have any way to have like resident code in cog that runs interrupts. That's not something we support yet. But people have sometimes asked for it. It might happen someday, but not yet.
That's something you've been able to support all those new features because, I get overwhelmed just trying to make them work in my own situation. I don't know how you make them work in yours. Like, how did you wind up using or how did you implement the tasks, for example?
Tasks turned out not to be too bad because the whole structure, the way I do abort and similar things had to be generalized a bit to work in BASIC with try. BASIC has these similar try catch blocks. And then C has long jump and set jump. So that whole kind of jumping between different stuff had to get pretty general anyway for the different languages. So it actually wasn't too bad to add tasks. The compiler itself didn't really have to change much, if at all. I just had to write some library functions that used existing features. Yeah. And similarly, like structs were not too bad because I already had classes in C and BASIC. So in effect, the structs are just like objects in Spin for FlexSpin. They're just objects that you can declare in line instead of being in a separate file.
I see.
Yeah. So just kind of a different way of thinking of things, I guess.
Yeah.
Yeah. Yeah, so FlexSpin does have BASIC, which is pretty similar to Microsoft Quick Basic or open source free BASIC. Some people really love BASIC. Some people hate it. It's I kind of really liked it for a while. But not many people use BASIC, so it hasn't received quite as much love as the C and Spin, unfortunately. But I will mention it from time to time just because it is people who like it really seem to like it. And of course, FlexSpin supports C, which is one of the major features we're going to talk about today. It generally supports C99, the C99 standard, which is it's still pretty old, obviously, but it's not quite as old as the original ANSI C. And I've tried to add a few extensions from C11 and GCC and C++. I added enough C++ in order to support other languages like Spin, so that like Spin objects look like C++ classes. And we'll get into that a little later.
Eric?
Mm-hmm.
I don't want to derail you here, but speaking of languages, and I discovered the Lisp package that came with FlexSpin, and I've been playing with that. And I'd like to be able to have that run in a separate cog and feed it things, but be running Spin or C otherwise as the firmware. Is that it seems doable? I just don't know where to start to do something like that.
Yeah, it should be doable. The C has a function called cog start. So you would just start your
start that as a function or on a cog? Huh.
Yeah, you can start any C function on a cog. So you would just, write your top level that calls into the Lisp interpreter and start that on another cog.
And feed it a file at the same time, or?
Okay, so you want to read the Lisp code. I guess I would start by reading the Lisp code into memory and then feed it to the other cog.
Okay.
Having multiple cogs reading files can get really dicey because the pins are tied to a cog, right? So.
Got it. Okay, thank you.
No, you're welcome. So the talk is mainly about mixing languages. So I hadn't thought about Lisp actually, because that's a separate, it's not part of the compiler itself. It's a separate program, but yeah, all the languages can be used in the same program. You can use Spin, Basic, and C. But you have to be careful of a few things. For example, C files are case sensitive. Whereas Basic and Spin are case insensitive. And also, of course, the file name, like when you're using an object, a C object in Spin, you need to include the .c. Normally, you can just say, object : foo and get foo.spin2. But of course, for C or for Basic, you have to explicitly call it. So let me just see if I can bring up my FlexSpin window. Just pause it. Sorry. There we go. So can you see my FlexProp window?
Yeah.
Yeah. Okay, cool. So here's the demo, which I gave the command line, but obviously if you have an IDE, you'd use that. This one has an example of calling a C object from Spin. So if you've got some code that you got somewhere else that maybe controls a device or whatever, and you want to use that from Spin, you can directly include the C file as an object. And then, so I created two objects, and I'll show you. This is just a really trivial kind of example. It's just an incrementing counter that also keeps a running total of all of the increments that have been made so far. So when you're using a C file as an object, ordinary global variables like int counter are treated just like member variables in Spin. They get initialized to 0, and there's a different copy in each object that you create. Static C variables, on the other hand, are shared, sort of like dat labels. So if you wanted to have a running count that keeps track of all the increments you've made, you can make it static and it'll be shared between all the instances of the object. So you can see here, I create the two objects. I increment A by 1, increment it again by 2, so we should get 3. Increment B by 5, so B should be 5. And the running total should be 1 plus 2 plus 5 is 8. So if we run this, sure enough, it all worked.
Hey, the comment on line 14 should be 8, right?
No, B gets 5.
Oh, that's the first time B's used.
That's the first time B is used. So A gets used twice, going up to 3. B gets used once, going up to 5. But the total, because it's in the DAT section, it's shared
Right.
between the two objects. So the total count is going to be 8.
Here, I got a quick question, Eric,
Sure.
regarding the static. So when I'm this is kind of new to me how we're using for multiple cogs and multiple languages and stuff. But usually when I use static in C, that in my mind that means that the variable is only in scope to that file, right?
Right,
So
for C, yeah. So
it's
this
kind
is
of like
slightly
opposite
different.
in my mind. No.
It's kind of more like static in C++. A static member variable in
Okay.
C++ is
Got it. Yes,
shared
understood.
in the class. Yeah.
It's a concept of static C++. Okay, got it. Yeah. So
Yeah.
it's like a class static variable so that it's globally accessible. Okay.
Right.
Thank you. Good.
So
good.
yeah, if you use a C file as a spin object, it kind of gets treated like a C++ file.
Great. Handy. Yeah.
Whoops. Where was I? Yeah. So that was the demo 1. Of course, an even more common use case is calling spin objects from C, because there's so many useful spin objects in the obx, and you don't want to have to reinvent the wheel or port all of your code to C. So FlexSpin has an extension, struct using, which kind of creates an object out of a file, such as a spin file or a basic. And then you can just call that just like a spin object or a C++ class. So I'll bring up the demo 2. Okay, so in this one I used John's serial object just because it's so easy to use and it doesn't need any special hardware to demo. But in real life, you'd probably use C's built-in printfs for serial, but you would use, I2C or SPI or whatever objects to control your hardware. So basically the struct using is just like an OBJ declaration. It's just creating a struct called JMX, an object that has the JM serial.spin2. And you call it just like you would a spin spin object. You call start with the baud rate, send out the string. Notice that the case, because it's spin, the case doesn't matter. Lowercase str or uppercase str, it's all the same to spin. And the compiler respects that. When you're in a spin file, case doesn't matter. If you're in a C file, the case does matter. Or in a C object, the case matters. And the same basic idea is used to call a spin object from basic. You can use something like dim serial as class using jm serial.spin2. And actually in both C and basic, you can alias that. Like you can do a type def in C, or in basic, you can do a type declaration to create an alias for the class using. So you don't have to type it out every time if you're, if you've got a whole bunch of I2C objects for different devices, you can just make one I2C type def and then reuse that over and over. And there's certainly some more interesting examples in the FlepProp distribution. There's a samples directory multi-language that has a Mandelbrot program that uses Roger's spin video driver from C. And it's got a Turtle graphics demo where it calls the spin video driver and the C Turtle graphics library from basic. So that's part of the FlepProp distribution in the samples. You can take a look at that code to get, you know, a little more realistic and complicated version of using spin objects. Now, another use case is using the C standard library from other languages because it's got a lot of useful features. Most notably, that's sort of a transparent file system support where you can treat SD cards or flash file systems or even files on the host PC. They're all accessed in basically the same way. You just change the mount call. So you mount an SD card or you mount a flash file system. And once the mount's done, as far as the C library is concerned, they're all the same. For Basic, Basic actually has kind of similar built-in features that they're a little bit more awkward to use, but you might as well use those. But for Spin or Spin 2, it doesn't really have a language notion of files and so on. So you can choose to use the C standard library from a Spin program. And I've got an example of that in demo 3. So I don't actually happen to have an SD card in my board right at the moment, so I'm using the host file system, but it's basically the same idea. Now, this program actually illustrates a few interesting points. So, for example, when you're calling printf here, you can't just say starting and \n like you would in C, because Spin doesn't treat backslashes any different inside a string. So to get new lines, you have to do either like string, starting comma 10, or you can put a %C in and put past the new line as a character. So that's what I've done here. So it says printf starting, mounts the file system, and here's the only difference between a host PC or an SD card is whether you mount VFS open host or whether you mount VFS open SD card. And there are various different VFS drivers. Evan has a new one for SD cards, which is much faster and lets you control which pins you use. And there's ones for the Parallax flash file system and for the ARM flash file system as well. So then you can create the file. Basically, if you're familiar with C, using this in Spin is basically just the same as with C. You use c.fopen. You just have to remember to put @ in front of all your strings because C and Spin have different ideas of what a string looks like. Whoops. Something went wrong here. Sorry, let me get that back. Okay. Oh, I see. Yeah. And you can use, all the usual printf, open, close, and so on. So if I run this, we wrote out the current system counter into the file, and then we read it back and printed it. So nothing too fancy, but it kind of gets the job done. And again, I've used that %C hack to get the new lines put in right. So as I mentioned, in Spin 2, a string like hello is actually a list of characters, which kind of makes sense in a way. But for C, we want a pointer to that. So we always use string, or even better, the new syntax that Chip added, the @. In Spin 2, using an array name all by itself refers to the first element of the array, whereas in C, it means a pointer to the array. So I had to... this got me the first time I tried it like with this fgets line. In C, you would just write line, but in spin, you want at line because you want the address of, oops, of line. And also, like I mentioned before, the \n or \r need to be handled specially.
Hey, Eric, do you
Mhm.
think you could add like some sort of alternate syntax that does the escape characters?
In spin?
Because yes, because doing the string brackets thing is annoying, and doing the %C thing in the printf is evidently silly.
I mean, it's not
Maybe
that
like
silly,
double
but
add or something. I don't know.
I don't know.
Add backslash. Oh, add backslash. That's
At
it.
backslash, maybe we could. I don't know if it's. On the other hand, you know, if you really want C, you could just write C too. I'm not sure. I guess it's up to Chip ultimately what we do in spin. I mean, there are times when it is handy to have the backslashes.
I think the add syntax was actually a FlexSpin thing originally.
Yeah, I think it was. Well, we suggested it first, but Chip adopted it. So
yeah, it was your suggestion. A lot of good ideas don't start with me; they start with you guys.
Well, that's the great thing about having a community. You know, where you get many heads together or better. Yeah, so we keep improving both languages. So yeah, maybe an @ backslash might be useful to translate some set of backslash escapes. Something to think about.
It would be nice if spin translated standard escape characters.
Yeah, I agree.
Like new line and tab and
right now, yeah, you've given me the whole list of recommendations for that. That's something I want to implement. I haven't done it yet. The trouble is it creates a little bit of a syntactical conflict with what already exists. And I don't want to break people's code like I have in the past by switching things up
That's
on
funny.
them.
You've never worried about breaking my code by adding features to spin too. You know how many times I've had to update full duplex serial because of breaking changes?
I'm learning.
I'm just giving you stuff.
I like Ada's suggestion of like @ backslash because that wouldn't break.
Backslash would mean that, yeah, that's a perfect thing because when you see the backslash, it means backslash escape sequences are now allowed.
Yeah.
And that's a great idea. I'm going to write that down so I don't forget.
I'm certainly open to doing that. So yeah, if
you've convinced everyone, Ada.
Oh no, it's my superpowers showing through again.
I think so, yes.
Yeah, that's perfect. That's the way to do it.
Okay, cool. Now something else I wanted to talk about in terms of multi-language is something that I kind of forget about, and I don't think it's used much, but there's a FlepProp and FlexSpin, actually the compiler, has support for project files that lets you group multiple files together, which simplifies compiling and grouping together different languages and stuff. And it also works for combining different language files. I sort of stole this from Simple IDE. There was a .side file, which was really basic, just a list of files and a few options for command line options. So I will show you what that looks like. Demo 4. So the file is just a list of files to compile together with definitions or include file commands. And it compiles them in order. The output is going to be called, like if I compile demo4.fpide, it's going to produce a demo4. Whoops. That's weird. That's there. That's there. Did I miss a file? No, they're all there. What's going on? Some files were not open, unable to open file demo for c.c. Okay, well, we have demoitis here. What the heck is going on?
Or gremlins in the machinery.
Of course. Or maybe there's a bug somewhere that I haven't. Anyway, the idea is that it will compile these 4 files together. Here's the C file that has code, and it can call the spin. So it's calling in spin. I'm setting up a serial object, and I provide a function spin init objects. The C code calls that function, and notice that I'm not using any objects or anything. All 3 files, the spin, C, and basic, are all kind of at the same level. They're all top level functions. So the C can directly call these spin functions. So spin init objects and spin print string, which just prints the objects. And it can also call the basic file, which is basic greet.
That's one idea. There's in the error there are 2 different types for text: a back tag, a demo, and a normal tag. Maybe there's an error.
I'm sorry, I didn't quite get that.
In the error message, the file is enclosed in 2 different.
No, that's just the way it prints the error. It uses 2 different.
Okay.
So there's a directory. It's using the wrong directory for some reason, which it shouldn't. So there's a bug possibly in the IDE. Let me see if I can bring a command line over, and I usually use the command line. I'm not sure what you're seeing now.
Looks like a shell window.
Yeah. Whoops, that's not right. Okay. I see what I've done wrong. Okay, it's getting the wrong. Anyway, I can go into the, I'll do it here. Into my talk. I can't type either. So if you, on the command line, it'll work, because I did test this before. So just FlexSpin -2 demo4 .fpide, and you can see it grabbed all the files, and if I load it, I'll use 9 dot just in case it wants files. So you see it printed hello from C, hello from basic, and it called a hashed so the spin here called back into C. So when we called spin greet, it called back to call the a C hash function. And if you want to call C from spin, you have to make sure you use the right case. So it's kind of nice to be able to mix the C. Like there's a lot of libraries in the world created in C for doing things like hashing or networking, or some device drivers are written in C. So you can grab them and just use them alongside your spin if you want to. And just kind of bounce back and forth between the spin and the C. So in this particular demo, I started in C. That's the first file in the FPIDE, right, is the C file. So that's going to be the main one. And it calls the C main function which calls the spin init objects, spin greeting, and then the basic greeting, and then the spin greeting. And the spin greeting just said the hello from spin and called back to C to get the hash of this string, and we printed that.
Eric, question?
Sure.
While you're talking about the entry point, if you reordered that and had a spin module up first, or you had a basic module up first, how is the entry point for the first file going to be determined?
For spin, it's the first spin method. And for basic, it's kind of implicit. In basic, there's a kind of default method called program that gets everything that isn't inside a subroutine or function.
Okay.
Yeah.
And then
in C, it's the main.
Okay, good. Thank you.
Another way you can mix languages that you can fetch code from other files. So you can add an annotation to a declaration to say that the function is in another file. And that's actually how the C library is implemented. You've probably all seen if you've looked in the FlexSpin header files. I think there's a define. Instead of from file, it may say IMPL or something like that. But this is what it gets turned into. Extern character star gets from file and then the file that it's in. So that tells the compiler when you want to call gets, you have to include the file gets.c. And you can do the same thing in spin and basic. In spin, we say pub file and then the file name and then the function declaration. And in basic, it's a little bit awkward, but I've tried to use the same syntax that Microsoft used, which is declare function, the function name, and then the lib and the file name, and then the rest of the function signature. So this is kind of, like I say, it's the way that FlexSpin internally implements the standard library. You only pull in the files that you actually use. So it makes the compilation a little bit faster. But it is awkward having to add all these from file declarations to everything you might want to use. So in a lot of cases, it's easier to just use an FP IDE file. I'm getting to the end here. I was just going to briefly touch on inline assembly, which we can use with C and with the other languages.
Eric, before you
yes,
go there, you mentioned that this is kind of a lazy inclusion. So only when you use the function does it try to go through that path, I guess.
That's right.
Good.
Yeah.
So that reminds me, is it does the compiler also remove I think there's been a conversation on this and I forgot, but it removes the unused functions. Is that also
yes,
true?
That's
okay.
a default. You can turn it off, but
okay, great.
By default, it does remove unused
Thank you.
things. Yeah.
Thank you.
So there's basically two kinds of assembly. There's inline assembly and top level assembly. So inside functions, we have inline assembly. And in C, at least in Flex C, that's done with a sort of like Visual C's syntax with an underscore asm, curly brace, and then the assembly code. And I will note here that the syntax is C still, even in the inline assembly. So like for comments, you use 2 slashes and not a single quote. And for hex, you use 0x and not a $sign. So that could trip you up if you're porting code from other, PASM where you'd use $sign or where you'd use quotes. So for inline assembly, it's a little bit awkward, but there's a way around it for the top level assembly. We'll talk about that later. Also notice that like I've got a 64-bit, this is a function returns a 64-bit value, a long. And you can access the individual words with like R+0 and R+1 to get the words of the 64-bit value. And there's actually 3 kinds of inline assembly. There's just regular ASM, which is optimized and mixed in with the other code. It's treated just like the stuff the compiler produces. So if your code, you know, if this function, for some reason, like if the return value of this function is never used, the optimizer may just take it all out. Or if it finds out that, you know, that some other things can be combined or merged, it'll do that. As far as it's concerned, the code you wrote is just the same as the code it wrote for regular ASM, and it's happy to do stuff to it. A lot of times you may not want that, so you can put a const modifier on it and say this ASM is constant. Don't optimize it. It's okay to run it in hub memory, but don't touch it. And the last kind is volatile, and a volatile ASM doesn't get optimized and actually gets loaded into cog memory before it executes, much like how spin does things. So a lot of times if you're, for some reason, porting code from spin to C, you'd probably want to use ASM volatile.
That's great. You got all that stuff covered.
Yeah, I tried to. And in spin, there's a similar, in the FlepSpin version of spin, there's a similar distinction. You can have instead of org, you can say org H. And that is like the ASM const. It'll just leave it in hub and run it in hub. It won't load it.
Maybe I could add that too, because I don't see why that wouldn't work in normal spin.
Incidentally, I think the normal org H has been broken in FlepSpin at some point.
It was broken. I thought it's fixed again, but
maybe it has been broken again.
I thought there were tests for it, but yeah, if there's a problem, let me know. It should work. So
I think it's just like a syntax weirdness. Incidentally, the VS Code extension also doesn't do it for some reason. So it's like double broken now.
Oh.
Syntax highlighter is broken and the compiler is broken. Interesting. At least last time I tried it, which is like some time ago.
Yeah. Well, it isn't standard spin, so I can't. We can't blame Steven for not supporting that in VS Code, but
he does support the ASM and ASM though.
That's nice. Yeah. So for this first case, in FlepSpin, you can use ASM instead of org to get this regular inline assembly that gets mixed in and optimized, which wouldn't make any sense for the bytecode. You know, the normal spin2 bytecode, but in FlepSpin, if you're compiling to bytecode, then all these ASMs end up getting put into loaded to cog memory, I think. Okay, so that was inline assembly, but in C you can also have top level assembly, much like that section in spin, which is kind of handy for global data or for programs that you want to run in another cog. And at the top level, you have a choice. You can use __ASM to use the C syntax, but you can also use ASM to get a traditional spin syntax. So you can use $ instead of 0x, and you can use quotes. Unfortunately, because it's a completely separate parser that's required, it's really hard to mix it inside a function. So for now, the __ PASM is only available at the top level. Someday it probably would be nice to let you use inline assembly, but so that looks, here's a little short program that just launches a blinking light. So at the top level, you've got like a DAT section, you've got PASM code and the loop to blink the light. And in main, you do a cog init and launch it. So, and that's about it. And you can see how I didn't have any time to make a nice final slide, but basically I'm going to throw it open to questions if anyone's got.
I have confirmed that orc-h has been fixed. Sometime between whatever my flex spin that's on path is, which is apparently December 11th, and February 11th, which is the one that I've got in the build directory.
So it seems to be working now?
Yeah, strange incident. I don't
Okay.
recall any commits to that. By the way, I do actually like look at almost every commit that comes through. I may have an obsession.
No, it's great. Thank you. You've caught a lot of problems.
Incidentally, have you seen the new pull request?
To add the CI, like a continuous test?
It does continuous test on a bunch of other stuff.
Yes, and thank you for that. And I'll probably add it once I've got them all working.
So that's good. I just usually want like an okay, this is cool, because sometimes I don't know.
Yeah, I'm pretty slow
sometimes stuff just hangs around.
Yeah, yeah, unfortunately.
Like, I don't know, just accurate with like an emote response or something.
Okay, yeah, that's a good idea. Thanks. Yeah, sorry about that. I'd like to do it because the more tests we have, the better. It's horrible when things break. But yeah, I want to get them working before I add them to the official tests.
Yeah, that's one of them has like a bizarre inlining issue.
Yeah, I saw that. I think it's miscounting the number of times the function's used somehow.
Bizarre.
Yeah, it is.
The other ones do work. I did test that it should in theory not error out if there wasn't actually an error.
Great. Thank you.
Any more questions for Eric or comments? Well, Eric, I just
yeah.
want to thank you. Oh, go ahead.
Oh, sorry.
Go
Thanks.
ahead.
Eric, you mentioned in the VFS printf library that that it uses you can use the SD card or the host. Is this where can I find out about how that's done? That would be good for testing. Is it like use the loader or something? Provide like a file system through the loader?
Yeah, yeah. The loader has an option -9 that uses the plan 9 file system.
Okay, got it. Yeah,
protocol.
P9, got it. Yeah.
Yeah.
The sticks back in the day.
Yeah. Yeah, way back when. But it's a simple protocol. It was easy to implement. So you can.
Wow.
Yeah.
Great. Okay, thank you. Good. That's handy.
Yeah, I use it for testing all the time because I don't always have an SD card handy.
Yeah.
Well, thank you, Eric. I don't know if everybody's aware, but you've worked on our C compiler work since somewhere around 2012. I was just looking back at some of the work you did with GCC with Ken Rose.
Yeah, it's been a long time. And FlexSpin and FlepProp have been around almost that long.
Yeah, and also you created from that we created simple IDE, and then also that enabled FlepProp. And then FlepProp has given us some multi-platform support too. FlexSpin.
Yeah. It started the ball rolling. I think there are better IDEs now. But FlepProp is an easy one to start with, and then you can move up to VS Code or Spin Tools.
Yeah, thank you. Okay, so before we switch over to Johnny Mac and Chip with some of the debug stuff they're doing, I think we'll show a short video that John Hoffman has queued up because the Propeller 1 has been behind the scenes in some very high profile flycam camera control applications in the last couple of weeks related to the Super Bowl, including flying down Bourbon Street. So are you with us, Hoffman? Maybe he's trying to find the unmute.
Oh no, there he's here, yeah. He's clicking on things, I think.
Okay, we'll give him just a minute.
Yeah, I don't know how to do this, so let me see. Share my
Incidentally, I'll
screen.
have to leave soon for a little bit for food
Thanks for
purposes.
joining, Ada.
Yeah.
I might come back. I'll leave the thing running. Funny people talking to themselves in the computer style.
Okay. Yikes.
And
Okay.
John, while you get that ready, maybe I'll post that YouTube link in the chat too.
Okay. Where did it go? Is it here? Here we go. Okay, so it's in my browser, but I don't know how
Now
to.
the green button on the bottom, share. Go to your Zoom window.
Okay, share. But it's not, so I just need to share my screen like that.
There we go.
Yeah, that works.
Okay. So this is on Bourbon Street in San Francisco. So you can see the wires or the ropes here that run down. That's what's supporting the sled.
Bourbon Street in New Orleans.
Yeah. And so you can see the stage down here.
Look at the revelers.
And they have the truss system right there with the Fox logo on it. And then he's going to just turn around. You can see the jib down there that they did the Lady Gaga song. I think they did that the night before this was shot. But this is running a P2 in their control panel, and the P2 is also running up on the sled. That gives them pan, tilt, roll, zoom, focus, iris, and then there's a reel with a motor on the ground. That's like a motorized clothesline, and that's what's driving it back and forth on the rope, and it's pulling the sled. But the sled with the camera and the gimbal, the camera gimbal for the stabilization, is all battery driven. So all that's autonomous up on the rope, and it's communicating over 450 megahertz modems to send the commands up and get data back. So that's there's another jib right there. You can see it sitting right in front of this, the anchor stage. But these guys are at all the PGA golf. They just did an AKC dog show down in Florida. They were at Pebble Beach and Monterey a couple of weeks ago. Waste Management in Phoenix, they do a big golf tournament. And of course, he was here for Super Bowl week doing all these, they call them bumper shots, where they go in and out of commercial and they're like, we're in New Orleans for the Fox Super Bowl, and here's all the people yelling and being drunk. So that's what this shot is for. So they ride this thing for the whole week, and I guess they did shows from here. I didn't watch any of it, but he sent me this video link so we could see it operating. So that's it.
That's pretty neat.
Yeah, there's some great shots, things that no other camera can do. And of course, you see these in a stadium, but they're like a 4-point reel system, and they connect them to 4 points in the stadium. But where this is just a point to point, where it goes from A to B and back and forth. So this is a lot less complicated to set up than the ones that are permanently installed in the big stadiums around the country.
You know, where was the Super Bowl held? I don't know.
New Orleans.
Oh, so it was actually in New Orleans too. Okay.
Yeah, yeah. That's
I'm-
why they set up here on Bourbon Street.
I see.
And if you
So-
take a look at the link I posted in the chat, it's a YouTube video with Lady Gaga, and you see everything from the camera's point of view. It's very impressive.
Yeah, that was another great video. You guys look up Lady Gaga, Bourbon Street, or whatever, you'll see the videos all over YouTube. But they used a steady cam, a jib, they used the fly cam, and I actually enjoyed the song. I was I was a little skeptical, but it was nice for a 65-year-old guy.
Well, congratulations, John.
Thank you.
Good job.
And thanks to Mr. McPhalen, or Johnny Mac, I'm sorry.
He goes by Mr. McPhalen and Johnny Mac or John, but don't call him Johnny. Johnny Mac, do you and Chip want to show the debug stuff?
Sure.
All right.
Do you want to do this, Chip, or do you want me?
No, go ahead. You're totally set to do it.
Okay. Let me, well.
And you've made better use of it than I have, so.
So where this is all born out, these are some, what I'm going to show is some recent additions to the debug crop screen. And what I'd call Chip about something else. And because I'm working with a next-gen display right now on a big work project, John's product, he was showing his ultimate product has a next-gen display. So we use them quite a lot. And in fact, one of those videos that Ken pointed out is now available to find easier. I think we did next-gen and either one or two of those. So it's a really useful display. And one of the things that I like about it is that it has this ability to they call them crop areas, where you can crop an image from layer X and move it to the display layer. And so it's really nice for making fancy buttons and light indicators and things like that, they're nicer than their widgets. So for example, in all the UI stuff that I've done with the next gen, I never used their button widgets or a lot of their other widgets. I used the text widget, and they have a numeric widget, which is just an extended text widget. And then I used the crop because their crop widget, and this is going to lead to a feature request to Chip, their crop widget has a pressed and unpressed event to it, and that's how you can flip images. So anyway, in a conversation I was having with Chip, I was telling him about this, and he said, "Oh yeah, that sounds interesting." And then the next morning, he sends me a text. He said, "Hey, I did it." And so what Chip has added is the ability. I guess I should share my screen. That would start.
It was like low-hanging fruit. I could see the value in it. It was like high reward for a little effort.
Well, it allows us to make really nice displays. Can you see my?
Yep.
Okay, so here's the code. So there's some new commands in the for the debug, and one of them that's critical to this is layer. So what this allows you to do is import into your plot window layers of images up to 3. Now, truth be told, I'm having troubles with a couple of things that we'll talk about in a minute, but this demo all works nicely. So I've got in this particular demo, which is a kind of like a lab thing, there's a switches 0 image, which is all the switches off. There's a switches 1 image, which is the same image, it just has all the switches on, and then this will display a value in a little window. So it's supposed to look like a little digital meter kind of thing. And since the crop window doesn't have the ability that I know of, forgive me if I speak out of turn here, Chip, and correct me, but I can't load an external font. I have to just use with the font that's inside, and I can size it, but I can't use, for example, in this case, I use a 7-segment font. So let's talk about the organization of this. So one of my favorite tools is Inkscape. I can get rid of that now. I don't need that anymore. So this is, so Inkscape is a piece of freeware it's really useful. So it's like AI, or not AI, I shouldn't say that anymore. Adobe Illustrator. It's a vector graphics program that's free.
It also means artificial insemination.
Yeah, I know. Yeah. In this, so what I do is I paint these screens. So for example, in John's Ultimate product, you know, we started painting screens, and John is I think he's got 60 some odd screens in his Ultimate project. In the Tower project that I'll talk about next month, I've got 20 some odd screens. And so now again, we're limited here to 8. So here's the off, you know, so here's a window for the display. This is a little radix indicator, and there are the switches. And I just drew these. This is how I relax at night. I'm not an artist, but I like to do semi-artsy things here. So if let me move that out of the way. If I go over to the layers, so you can see this is the switches off. If I show the switches on, there's the on position of the switches. And now, important of that is because you can swap in the whole layer. So if you just say crop and you give it a layer number, the entire layer will go into the display. So that's where we start. And if you want to just, if let's say you were doing a multi-screen piece of equipment or lab equipment, you could swap to the things. But for partial layers, you know, we need to know the zones. And so what I do is I create another layer that's translucent, and that shows me where all the zones are. And so I have some overlapping things here, but you notice this blue one, that lets me set all the switches to 0. The yellow ones are individual switches, so I can flip them. And then there's the radix indicator, and there's the display. So, you know, you paint all these things, and then you go in and you know, the system will tell you the coordinates of a thing. And now in 4.9, so this is a change that people need to be to know about. In 4.91, the crop image, you have to give it the upper left corner and the lower right corner. But Chip is going to change that, so you're going to give it the upper left corner and then the width and the height, which will make it much easier, especially for the way I do things here, because I can click on this and I can see there's my upper left corner, there's my width, there's my height, and makes it very, very easy. For those that want to give Inkscape a try, you can go to inkscape.org. It's free. Now, the only problem is, so if I want to, let me just have a visible layer. So if I want to export this, I can go to the export page, and I'm going to select page because I have the page defined as 320 by 200, which is the size of my image. The only problem, and I'm doing problem in air quotes, is that Inkscape only, well, it doesn't export a BMP file that Chip uses. So I export it as a PNG, then bring it into another program and do a, you know, just bring it in, save it back out. So that's the only thing. I'm disappointed that there's no BMP export in Inkscape, but that file format doesn't get used very much. That's probably why. So that was the main screen. And then here, like I said, I wanted to use this 7-segment looking font. Just, you know, again, this is for arts. And before anybody says, hey, this is not very useful, John, this program, I know. This was for me to learn how to use the graphing thing and test the crop stuff for Chip. So here's a way, you know, I wanted to have a custom font. And since there's only 17 characters, I allow for negatives, not in this program, but another. There it all is. And you'll see that each one of these digits is 30 by 50. So one of the aspects of crop is you can say crop from this image starting at a X position and then a lower position. Again, that will change to width and height later, but that's how I can just multiply the digit value by 30, and that gives me my X. Y, the first Y is always 0, the bottom Y is always 49, and then the other. So it's really easy. Now, one of the things Chip and I are exploring, because we're having troubles, what I was originally doing, and I kind of fixed it while I was listening to Eric, in the program, you'll see that you can click here with the left mouse button, or you can right click anywhere and it'll change the display radix. And so I thought, well, it would be nice for newcomers to see, well, when it's in hex, which one of these switches are associated with the digits, and I also put octal in there. So I had created these small graphs to display right here, but for some reason, these small images are not displaying correctly. These other ones work just fine. So there's still some stuff that we need to look at, but it's useful. And I'll show you with this. You know, I was kind of motivated thinking about Gavin Garner and, you know, his students. They do all kinds of cool stuff with the P2. And so I was thinking, well, you know, how neat would it be to make a little piece of lab equipment where you could turn on a switch? So in here, if I click on a switch, you know, it shows it's turned on, and then it shows the value in the display. And so right now it's in decimal. I can switch to hex. And so here's what I did is I just used the line function to show the bits under each digit. There's binary. I don't bother doing every switch because there's 8, and then octal, which, you know, we can do 3 digits with. So this is using the mouse input and the crop features of the new display. It's pretty easy. It takes a little bit of planning, so, you know, do that first. But the code is fairly straightforward, as you can see. So here's toggling a bit. We send it the bit that needs to be toggled. I have a global called display value, which was that value that was up in the display. And again, because I've planned layer 1 is the off position, layer 2 is the on position. So this layer value gets set by whatever the bit is plus 1, and then based on the bit, I know which switch to flip. So these are all the crop coordinates. That's why, again, this is why I go through at first and I paint on top of all those things and organize it really nicely. One of the great things about Inkscape and other programs is that I can set the environment to pixels. So everything is happening in pixels. And so it's just easy to find all of the things. Now, this is obviously all computer stuff, or all, you know, there's no external attachments. But my friend Josh at the laser tag company a couple of weeks ago asked me to write him a driver for the Sony PlayStation controller that he's going to use on a project. And so I did this one. Now this one is just a you know, show me kind of thing. Let me grab my controller. And right now I have it connected to a genuine PlayStation controller, but I have tested it with the wireless ones that come from Amazon. But in this case, it just, you know, when I press a button on the controller, it shows me on screen. Now, before I release this, I'm going to go ahead and put the data stream that's up there, and you'll notice it's in analog mode. So those red dots show the position of the joysticks, and then I write the text there. One of the things that's important on this program and to think about is to put, since these red dots are being painted over this area and the text is being painted over that area, because watch, I'm going to press down on the right joystick. You notice how the background turns white? There's a button in the joystick as well as the joystick. And since the graphic, you have
a draw order that allows
yes,
all this to work.
The other thing too is to make sure that you instantiate the window in update mode. So you do all of your updating and then do one update, and then you get, because before I knew how to do that, I was getting weird flashing of the red dots and the text. And in fact, I was going to call you and say, hey, can you fix this? So it just updates when I want it to, but I thought, well, I better check the docs first. And I found it was there. So you see, this looks very nice now. I don't have any weird flashing or anything, but to your point, Chip, yes, I do the digital stuff first. These buttons are drawn. And then after I do the joysticks, which does the red dots and also their position values. But, you know, on this controller, there's a small button and a big of these triggers. So, you know, this I did some artistic license on to show. But
Nice.
this is the same kind of thing in Inkscape. Let me turn this off. My for whatever reason, my computer fans go crazy when Peanut is in debug mode. So
It's because it's having to like take a lot of CPU time to not be late. It's to cut down latency on messaging over the serial port. If we don't do that, things get all strung out and you don't get very good response. But yeah, I got to be sure to like hit escape before I leave my office. Otherwise, my CPU fans worrying real.
yeah. So this is the graphic that I drew. Now, again, anybody who's a graphics person knows more about this stuff than me. What I did is I went to the internet and I found an image of a controller, and then I just traced over it. And I actually only traced half of it, and then I mirrored it and did some adjustments. But here again, here is the off mode, and then you'll see by doing everything in layers, it makes it really easy. So I could say this program only uses 2 images. So it has the off mode and then the on mode, which shows all the buttons in their on state, including, you'll notice one of the things that's interesting about this, you notice this little red light here, that has to do with the analog. And if I go back and rerun this, so I am using spin tools here, but I'm running this through Peanut, of course. So I have the external tool set up. So you'll notice this red light is on, and if I turn that off, now you notice the interesting thing, when you turn off analog mode, it doesn't send the entire packet down. So you notice that the joysticks are not moving, even though I'm wiggling around and pressing buttons. So all the joystick stuff, including the digital portion of it, which is interesting because that's in a different part of the packet, is shut off. But again, this was just for a demo, and so that I could send some test code to Josh with the object that I wrote, so that he can make sure everything is working the way he wants before he hooks it into his project. But I think, again, I was just was inspired by, I think Gavin and his students, they asked for a lot of the sprite capability and some of the other graphic things. The nice deal with this is that there is no code. All that graphic stuff is external. There is no, there's no image files built into the programs. We're bringing them in externally.
You're just cropping things into a composite.
And just cropping them in,
and then updating them.
Yeah, so there's kind of 3 ways to crop, if you will. So you see here, this crop just puts this entire layer in the visible, we'll call it layer 0 is what's visible. So that does the whole thing. So that's how I start this screen.
That's like the empty undrawn controller.
Yeah.
Just the body of the controller.
Then if you have a section where so for example, I'll go back over to the switches. You'll remember, or you may remember, I had this blue area here. Another thing that I did in the switches program, which I'll post out in the forums, or a new version of it. I think there's an older version, but anyway, the switches program, if you press a space bar, it turns off all the switches. And so what I'm able to do is take this zone and not that one, the blue area, that zone, and crop it
like
from layer, the first layer, which is the off layer, to the display layer, and that shuts off all the switches. So what I'm actually doing is seeing,
Say good day to unforgettable Australian views.
That
from up here to way down.
That's not me.
Ken's gonna get it.
I'm after him.
At any rate, so again, this appeals to me because I really like the next gen. And as I can say, my friend John Hoffman and I have done lots of things for his products with it, and I use it at laser tag. It's just it's a neat display, and so that crop feature is really nice. And I know I give Chip a lot of grief at times, but I appreciate him for doing this kind of stuff, because I think that this can turn into some really neat things. I'll probably, before the event in May, I'll try to make a little video game kind of thing. I'm learning a game engine, so I thought, well, I'll apply some of the things I learned to this, just as again, wouldn't be practical, but it would be a way to inspire people to, play with the propeller.
Yeah, that's a really powerful idea. I remember looking at industrial displays like human machine interfaces and thinking, man, they must have some amazing graphics libraries in these things. But that's not what's going on at all oftentimes.
Most
They
of the time,
simply-
no. Yep.
Yeah, it's just simple pre-drawn graphics that they're just cropping into position to
Yep.
make the composite display. And there's a lot of flexibility when you have things like digits and then in the way we do this in the plot windows, once you draw up your thing, you can then overdraw the top of it with really nice anti-alias lines or shapes from the plot drawing commands to augment it. So you don't everything doesn't have to be croppable. The cropping can just be your base image, and then you can dress it up with all kinds of other detail.
Well, again, that's the case with the joystick. The red dots here are being plotted in. Those are native. That's a circle command, you know, there, and then the text here. So you can combine that. And then what I added, let me go back to the other program, the switches program, is that oops, it's Alt-2, not. So when I switch the radix to hex, you see these are just line commands there. Although I will say I wish the line command would also I wish there was a version of line that would let you put in X, Y, and length. Or maybe, and then call that H line or something, so that I don't have, because in this case, you'll see I have to, for each of these lines, I have to, since they're broken, I don't have them going one to the one. I have to, in this case,
set and a line.
Yeah, so in this case, I don't show for decimal. I do for hex. So here's the hex. So I set the first point, I draw the line. I set this second point, I draw the line. It'd be nice if I could get this down to just 2, you know, where it was like H line, where it was X, Y, and width. And then so something to think about.
Yeah.
Same thing here, because the radix for octal has, we can show 3, we have 3 digits. So I have to do that 3 times there. But again,
we could have H line and V line.
Pardon, yeah, H line, yeah, there were our height, width, and it would be starting point and either length or height. And then, you know, and then if I needed, like in this case, I'm assuming I could set that once up at the top and it would take it all the way through. Is that correct?
Is that the line width?
Yes.
Yeah, you can just.
Okay. Yeah, again, I was rushing this, you know, I was trying to, because the graphic version of this wasn't working, and I want to show it. But this goes to your point, Chip, where you can have the you can do your cropping stuff, because I in the order I show the switches, then I show the value, then this, which is normal text over the top of a crop. The crop is just used to clear the window. And then the lines the same way. I clear out this section and then redraw the line if necessary. You see, you know, so here's where it is. That this does a crop from layer 1, which is the clear layer. This sets the color to gray, and then if the radix is 16 or 8, it does the lines on the screen. So it's again pretty easy to do, and in my way of thinking anyway, it makes really nice displays. And again, you know, if I was one of Gavin's students, this is what I would be doing for my lab stuff with the P2. You could make it, you know, I've just shown, this is all just inputs to the screen, but as the other things showed, of course, you know, with the joystick, we can take inputs from the outside world and display them. And of course, you know, we could certainly control pins since the debug window can change things, we could, you know, make lab equipment so that outputs, say, you know, an analog voltage or something else, or control some piece of equipment. So again, my point is, you know, it's another way to do things. And my reasoning for all of this, going back all the way to the beginning, was I've got a big complex project I'm working on right now. Most of the things I work on with Jon are fairly complex, and it would be nice to have a visual debug when we're doing P2 stuff, that where we don't have to look at a screen and see, okay, and analyze values. If we could see it visually, you know, it'd be much more effective.
Agreed. Yeah. Well, we need to send Gavin the link to the video with a time marker where we discuss this.
Yeah, and I included him on one of the demos that I sent to you and Ken. I included him on there because I haven't seen him in the forums in a while, and it kind of miss his presence. He's, you know, he's done so many cool things with the P2, but it seems to me that this is right up his alley since he had asked for the other things.
Right.
Yeah, I'll be sure that he sees this.
Well, super, John. You did a great explanation of this.
John, I think I missed something. I was wondering, and it's probably obvious to others, but do you get to do double duty with some of this work using the next gen, like the same graphics?
When we get width and height, it'll be more so.
Yeah, it will be easier, but it's the same process. I mean, you know, hang on one second. Let's see if I can.
Are you ever using the same bitmaps in two places?
Well, I'm thinking about it. Let me find.
Seems like it could be a good way to model for your customer what they'll see on the display before.
Well, that's what I was thinking too. And so the let me find. Sorry, I have way too many. Let's see. Tower. My desk isn't blowing up. Somebody just texted me.
I'm also wondering too, since you and John use those displays, if we should get some on hand for the Propeller Developer Day.
Is it here? I can't. I have so many folders. What I wanted to show you. Oh, there it is. You know, called. But just to give you an idea of, you know, of how involved this can be. And John's, like I said, John's is even more involved than what I'm doing. But here's the product I'm working on right now, P2 product. So this is a 320 by 200 display.
We need more layers, huh? How many should we put in there? Like,
well, these are. Oh, I see what you're saying. Yes, you're
oh,
right.
But wait, we can load them dynamically though. We right now we're limited to have 8 layers at once, but any of those can be reloaded with the debug command.
Oh, all right. Well, that would be a little advanced, but so here you can see, yeah, this is this battle tower thing. And so here is exactly that you know what I was talking about. You know, this is what motivated me to ask Chip about this. Here's our main menu screen. It's got these fancy buttons on it, and when you press them, now here's the interesting thing, Chip. I don't know if this is possible, but it'd be really nice if there was a press and release kind of thing. So what happens in the next gen, since it's a touch display, if I'm showing this and then I press on this button, it lights green until I release it. So there are press and release events that you now since it's event driven, maybe that makes it easy. But
yeah, and it's also a coordinated touch screen, so that's
yes,
one-to-one mapped.
Yeah. Yeah, so I don't know if there's a mouse. So I was thinking, could this be done with mouse down or mouse up? Is that possible with implementing that with the mouse? Because that's how we're going to do it here. If not, it's not.
Okay, well, here's the thing. It's the host is only getting messages when you send them, right? It's not event driven because that would like reorganize how everything's working.
Yeah.
So you have to kind of, you know, be on the lookout, and then when that occurs, you have to do it. I just don't know how we can make it fully.
Yeah, it's on the, you know, because if I was doing this kind of thing in P2 debug, I would just use a click event on this. And if I really wanted it to be fancy, the click event, I would light up the thing and then jump to the other screen. I mean, you know, so because that happens actually in the next gen, in this code, this screen doesn't do anything. Well, the screen that holds these two images, it's actually looking for the release event. It doesn't care where you press, it cares what got released. And then that's where it jumps to the different things. But, you know, so here's, you know, the buttons here, you know.
Oh,
these
so it actually navigates menus in an
Yes.
automated
Yeah.
fashion.
So when the thing starts up, it shows this screen, and then it looks for the P2. If the P2 isn't connected, it will show this screen. So there's a timer in the Nextgen. So using the Nextgen is like having a 9th cog with its own high-level scripting language. It's a little bit like C. So that's how the user knows that everything's fine. If the P2 talks to it and says, "Hey, you know, give me your internal information," then it will jump right over to the menu, and then you go through and, you know, set the games. You know, we have right now, we only have 3 games that we're implementing, but we've made space for up to 8 down the line. So this page never gets displayed at for the time being. But here you can see again what I was talking about with the zones. I do the same thing here. What we were running into a problem when we were showing this in Florida, that because this is a mechanical display and it's built into a piece of, you know, a base that has a bevel in it, people were having a really hard time with these corner menu items because I was being really persnickety about the zone. So what I ended up doing is growing the zone, and then I put it onto this display. So just as a reminder to myself.
Yeah.
But, you know, so this is, you know, hours and hours and hours of work. And, you know, here's a particular case where I actually have 3 layers for one screen, because it depending on the mode, if it's a generic device, because we can have up to 16 of these things on one field, it could talk to any of the units out there. But if it's what we call a master controller for the hardpoint game, it knows how many satellite devices that it has. And so in the master mode, it will, you know, it will be 0. So the 0 will be disabled. And then if we only have 2 satellites, which is a standard, then 3 through 15 will be disabled. So that comes from this layer. So again, all of this from a computing standpoint inside the Nextgen, it's all very easy because the crop widget is very simple, and there's no nonsense to it. So I from my standpoint, I think it's worth the time to do this because I get a display that looks exactly the way I want. What I ended up doing is after I did this, I pasted all of these images with explanations into a document, and I sent it to our sales team, and they gave me feedback. And so now we're proceeding forward with the code. But, you know, there's a thing, I'm going to try this. So maybe I'll try this screen in the window chip, because this is an animation. So when we get to the ready mode, so you say, hey, we're ready to play, this little spinning, this bullet spins around and it's waiting for the game start. And so there's an animation that is, you know, it flips like every, I don't know, it's about 50 milliseconds or so. So you get this little whizzing bullet display. So I'll try that to see if it's possible. Because if you were on a screen, if you did a screen-based thing in the debug, you know, we could always use the poll weight or poll count rather, or something like that to do the animation. You know, and still be checking other things. This also shows we have a couple of modes. You know, we have the infrared mode, which just shows these guns here, and we have button modes. So we show that. So it's a, you know, it's a really tiny display, but we are able to use it with some you know, somewhat nice graphics. I think, you know, I did them, so I guess I have to think they're nice. But it's very easy, and you know, when we showed our customers, they really liked it and they understood it right away. In fact, one of the best kind of compliments of, you know, our efforts in the design on this was that we had our competitors' customers coming to us asking if we would make that game piece compatible with their products.
Neat.
Anyway, this is the Nextgen stuff. This is what inspired me to ask Chip to do the layer thing, and I, you know, I'm appreciative that he did, because I think it'll allow us to do really neat things with the debug. Just a little imagination needed.
No, it's good. It's good to kind of just talk about this, because I was always intimidated by these fancy displays trying to figure out how they came to be and what does it mean? How much work do I have to do to make all that possible? But this is how it's done. It's with pictures that are cropped for each other.
You know, I live a mile from Disney Studio, and you know, every cartoon they ever made was one image at a time, and so you know it's just taking that concept and applying it. But hopefully, you know, what I've shown here and what I showed, you know, with the Inkscape, it'll cause people to think. And you know, as when Chip and I talked that day, I remember, and Chip brought it up earlier. Do you have that program that Carol wrote, Chip? I'm trying to find it. So
No.
for those that are wondering who Carol is one of the members of the forums who at one time worked for NASA, I believe. And in the early days of the P2, you know, debug window that did the plotting, he made a NASA-looking display that was based on something, I think, from the LEM, the landing module for the moon, and it was really neat. But he had to hand draw all that, so he was using line commands for everything. This he could probably, using this one, he could probably create several blocks on a graphic and then plug them in where he needed. And then make them, you know, my switch thing, you know, it doesn't look like a photo, but it looks nice, you know. Look, you know, and you see, you know, these images, and for those who, you know, don't want to draw their own, you can go do a web search for widgets for phone apps. They're all over the place. People make SVGs available. So SVG, for those that don't know, stands for scalable vector graphic. And so the nice thing is they're infinitely scalable. And yeah, it's just, like I said, I like to draw these kind of things just to help me relax at night after I've had a long day. You know, maybe it's weird, but, you know, one brother is a painter and another brother is a sculptor, and you know, I do a little bit of acting and writing. There's an artistic side of the males in my family, and this is kind of the art lately that I really enjoy doing. You know, that's in fact, you know, one of my, I think it's my Pinterest page is called Techno Artist, you know, for all of the stuff I've lit up, you know, in Hollywood and other places.
This is so cool, John.
John, there's a comment in chat for you too.
Oh, okay. Go ahead, Eric, and I'll look at the chat.
Sure. I was just wondering, do you have to use Peanut to compile this, or can you compile it with Marco's compiler and then run it with Peanut?
No, well, yes. So right now it has to be compiled with Peanut. You'll notice if I go over, Marco is showing some errors. So I'm editing right now in with Marco's tool, and then I'm using sorry, I've got getting rid of the windows, but if I go to I have Peanut in different modes set up here. So if I do Alt-2,
right. I guess maybe my question's for Chip. Is it possible for Peanut to just run a binary so that someone that used a different compiler can get the benefit of these debug?
Yeah, then you have like really any kind of compatibility. Sure, if it generates the stuff that the current Peanut recognizes, then yeah, you can do all these kinds of things.
Yeah, and on that point, Marco responded to my post in the forums about this crop function, and he is in works making it native to spin tools. He has basic debugging in where you just, you know, the text debugging, and now he's going to support this as well. And because he showed some graphics that I had provided with my other thing, so that's coming. But I think what you're getting at, Eric, is just as I'm using Peanut as an external tool, somebody could use FlepProp as the external tool and then run it through Peanut.
Yeah, that's the idea.
Or compile it in FlepProp, and then so yeah, I mean, you know,
so someone could run like a basic program or a C program,
right,
and produce these same kind of graphics. Yeah, that would be cool.
I'm not sure why I brought that back up, but yeah, so this is just edited in Spin Tools, compiled and running the graphics through Peanut at the moment. Yeah, and you can see that here down the debug window. This is the command line. you know, for Peanut that's saying, you know, run it in debug mode. Yeah, so I'm just using for the time being because, you know, Peanut is too sparse for me. I like a little more fancy in the editors. You know, Propeller tool kind of spoiled us with the nice backgrounds, and you know, Marco's done a really nice job with the navigation pane and other stuff. And I know there's some other things coming. He and I occasionally converse offline because we're both Formula One fans, and so there's more things coming. But you know, I mean, we're lucky in our community. We have, you know, the coolest piece of silicon on the planet, and you know, more and more tools. You know, the silicon doesn't run without the tools, so it's nice that we have, you know, all of these choices that we can get the job done.
John, you can always run though the latest version of Peanut from Marco's tool, right?
That's what I'm doing now.
Okay, so it doesn't matter if he's natively supporting these debug things or
Yeah,
not.
no. Yeah, no, I'm saying for the time being, I'm
Yeah.
doing it through Peanut. You know, that one of the things that I did ask him, you know, and you know, kind of nudged a few times is, let me use your tool as an editor and then compile with Peanut or FlepProp, because there are, you know, Marco actually has some C support in here. I've not used it yet, but he, you know, he's a C programmer, so he wants to do that too. And so I'm sure there are people, you know, I couldn't name them, but I know there are people that are using spin tools, but compiling with FlepProp, especially if they want an assembly program, you know, output.
Yeah, and
again,
so
it's nice. You know, I asked Marco, and he did it. Now I'm sure others did too. You know, said, hey, can you give us the opportunity to have an external compiler?
yeah, and Eric, you can always you can run Peanut, just open it up in debug mode, and it'll just listen for any command. So anything that's sending serial data can drive all this debug display stuff.
Okay, so
oh, that's
well, I guess can you use Peanut just as a loader? Like, will it load a raw binary and then
Yeah. We've got
okay,
lots
cool.
of variations on that theme supported now. And yeah, you can just load a binary and it'll run it. It'll open up debug if you specify, and it'll just take in these commands and
show them. Oh, very nice. Thank you.
so
Sir.
if you're creating the ASCII to call these things out, it will happen. However you're doing that.
Well, John has certainly shown us that there's a lot of really interesting things you can do with these debug statements.
Well, you know, and I will claim no originality. I've, you know, seen how other people have done this stuff and thought, hey, I can do that. And again, it's I think that, you know, my artistic side likes to have, you know, likes things to look pretty and nice, and this is a neat way to do that.
All right, well, thanks for going over all that.
Okay.
Thanks, John.
I have got some, I've enhanced the compiler in various ways. Let's see.
Chip, I'm going to shift the host over to you while we're at it.
Okay.
Also, hello, I am back from eating.
Oh, good. All right. Let's see. How do we, where is these? Oh, here it is. Share screen. Okay. All right. So here is a, let's see, what have we got? This is the Google Doc that shows all of the latest compiler changes. So last month we went over all this preprocessor stuff. So what's new now are these things here. We have, so con structures that are declared in child objects can now be totally accessed, you know, via the parent object. And there are more forms that I'm not showing here. But anyway, that was hard for me because at first I was keeping everything separate. Like one object would reference another object, and I would point to it. Well, this creates this like volcanic explosion as things move upwards from child to parents and so on. And so what I did is I just started packing all the structures, like subsuming substructures into the structure that you're declaring. So every structure stands on its own. There's no references. So this made it possible and very simple to bring child objects up into parents. And you can even do this where you can say, like, if you want a local structure that's just a copy of a child structure, just use this form. So, just say my struct equals the object, whatever struct you wanted. So that's the way to kind of make things into shorthand if you don't want to always have to be typing this, So let's see. Did we last month talk about how logic display now does multi-bit groups? So you can draw, I wonder if that was a whole month ago. The logic display, which is, I'll show you down here. Let's go way down here. This thing here. Okay, can you guys see my cursor?
Yes.
Okay, so that's the normal logic display. So now there's a thing in here where you can, let's see, where is it? You can do this range thing. See that keyword? And what it will do is, see, like I said, low in this example here, I said low has 3 members, right? So it drew low 0, 1, 2, all bits. But if you say low or some name and then a number of bits and you use the word range, it'll express that waveform now as like an analog, right? So you can see something ramp up or down or sine wave, whatever. So that's very important because there needs to be a mechanism where you can see time-aligned data in both bit form and analog waveform. So I didn't prepare any. I have something, but if I try to load it up, it may not work. Well, let me see if I can just pull it up real quick. Let me make a new instance of PNet running here. And I believe, let's see, plot layer. Oh, okay. I don't see anything that looks like it's going to be a sure deal. Anyway, that's in the latest. That's out in the current version 49. Okay, and going back to where we're at with the release. Also there was a minor bug in all of my anti-alias line drawing stuff where if you had a line that the slope was 1, it would start drawing like horizontal and vertical pieces because of some incomplete optimization I did a while back to that line draw routine. So that's all straightened up now. So if you saw any aberrant lines, those should be gone. Okay, so here we just went over all this stuff with Jon. That's implemented. Oh, I have to put out a version 50 that's going to contain all this stuff. So what I've done otherwise is I have made this new thing. I was doing a job where for Doug, the guy that designs all the automation stuff that used to rent my shop. He's paying me to make a motor controller system for him. And it came up that what we really needed to do was, in order to make efficient high-speed PASM code, we need to be able to like replicate blocks of code. So Stephen and I talked about this, and he came up with the name Ditto, which is perfect. I started using repeat, but that's like a semantical kind of conflict. Anyway, Ditto, if you say Ditto some value, what it's going to do, it's going to repeat whatever's between that and Ditto end. And so, like in this little case here, this expands out, and you get this code resulting from that business between the Ditto directives. So this makes it super easy to make like parameterized objects where you want to have like dynamic code generation based on some parameters. Because if you had to, without this mechanism, you kind of have to code it so you either jump ahead to the thing of interest and reverse order it or whatever. But now we have like dynamic generation within dat blocks. And you can even use this to like come up with lookup tables if they're formulaic. You can put some kind of formula in there and generate fast lookup tables if you don't want to have to compute something. You just want to look it up. So this is a new thing, this ditto directive. And then if you want, you're going to have to do this. If you want to, use it, you're going to have to say spin2 v50 when I put out version 50 so that ditto keyword will then be recognized. Any questions on any of this stuff?
Aren't we still missing the like if else stuff in that section? I don't think that was ever implemented in Peanut.
Okay, do you mean like this kind of thing?
No, the like semantic if else, which uses constant symbols.
You mean for like pre-processing? You don't mean pre-processing, right?
No, I mean the other one where you can use like a constant, but
like what would, I'm not understanding, like what would the use case be?
I can show you what the use case would be, which is if you have a bunch of constants that configure things in the object, and you want to include or exclude code based on the constants, but not just the constants directly, but like I need this function if either this or that is enabled.
Oh, okay, all right. Well, so it is kind of a pre-processing thing, right? Or do you want the compiler just to selectively skip it as it encounters it?
The latter, because the preprocessor obviously can't use any computed constants.
Right. The preprocessor is a separate level thing. Yeah. Okay. So, yeah. So this would be if def, or no, it would just be some. Okay. So what you're talking about is in the dat blocks, introduce some sort of conditional syntax so that you can selectively include things. So it's a compile time if that affects data.
Yes, we already have this in FlexSpin because I tested for it. And I use it in like the USB driver thing. So you can see that as you can link where that lives.
How complex is your computed value?
It's really just, in most of these cases, it's just this and that or something like that. I have to check. I think there's a few ones that may be more complicated.
And what's the reason that you can't do it compile time, but you have to do it runtime?
It's not runtime. It's at the compiler time.
Yeah, he just doesn't want the
extra pre-processing.
Then are you just missing operators in the preprocessor?
Not really, because
yeah, he wants parameters and things to be usable, which at the time of the preprocessor, those are not even looked at yet.
I'm still trying to.
So yeah, he wants something that's like it'll do what a preprocessor does, but with contextual awareness of what the con symbols are. Because the preprocessor hasn't processed any blocks yet.
Yeah, essentially there's some ones that are actually, if this is larger than 0 and stuff like that.
Okay, so what do you think that would look like? Just the word if?
Yeah, and you need an end at the end. You can actually just look at this and just search for a couple.
I don't think you're showing anything yet.
No, I've posted it into the chat, but I can I couldn't share screen if Chip was doing it at the same time.
I'm looking at it.
Even if I wanted to.
No worries.
This is the world where we live in.
Yeah, I know. Things aren't really choosing to work or not.
Okay. Okay, so let me just go there and we'll just show your site.
Trying to find some. I see.
Okay, is this what we should be looking at?
Yeah, just search for if space or something like that. Then you will find all of them.
This bumps up against the discussion with dat names too, doesn't it?
Oh yes, this all comes together. Search for if and then a space, then you'll find it easier.
Wait a minute.
There's a bunch of.
It's going to be in a dat block is where we're looking, right?
Yes, you have to go down a little bit to get into the dat block.
I see if activity led, if error led. Those are the statements you're looking for?
Because there are conditional. Here we go.
There we
right?
go. They've got one.
All right. Well, that's understandable. So it's nestable and
Do you have positional requirements in FlexSpin for that if?
I guess it doesn't. I don't know if it. I don't think you could make if as a label to begin with, so probably not.
So then it must be the first thing on the line, ignoring white space.
Yes,
And
obviously.
If is terminated with an end.
And there's also the option to have else and else if and all the other ones.
Oh, great.
yeah, it's harder for Stephen than me to implement that because of the geometric implications to his highlighter. Right, Stephen?
No kidding.
I mean, there is a bit of a problem where if you don't know what the constant is going to be, you don't know which version of the code is really valid.
Correct.
Or squalid.
You don't know which code was generated. Is that what you mean?
Yeah, so if you have a label in the label that's in the else block, which one do you use? It's kind of
right.
But other than that, it's actually not that complicated.
But it is a pre-processing of the dat section before you can compile it.
Yeah, in that sense, yes.
Well, it's not exactly a pre-processing.
No, you can handle it
at a later stage.
Right, but I'm saying
it's a lot like the ditto.
Okay.
Yeah, that's why I brought it up now, because it was relevant.
This would be like a ditto 0,
so
I guess,
saying,
if the condition fails.
So what you're saying, Eric, then, is that you can choose to eliminate or consider lines based on evaluation of the constants mentioned in the math.
Yeah.
So it's a conditional enable or disable.
If I made ditto handle the value 0 as an input, you could just say ditto, and then you could have a whole expression like an equality.
Yeah, I was thinking that, but it's
and
like
then do
mildly annoying to do that.
But then do a ternary where you say question mark 1:0 or something, and it would either, you know.
Yeah, that's what I was thinking. You could abuse that to make the same functionality essentially, but
okay,
like
so
annoying.
maybe so if
Hold on, Chip, hold on. That's not nearly as readable.
No.
So be careful with that.
It kind of is.
We have to pay attention to is you really want the code to speak to you as rapidly as possible about what's going on, and not have to decode it.
But essentially, the same sort of backend implementation is like it does the same thing.
Right.
Yeah, under the hood it can be the same, but yeah, the user should be able to read if instead of ditto for this kind of case.
Really. Now, are you liking or not liking the fact that it's spelled if without any preceding character, and the same thing with end? Because
that's actually something I thought about, because the if in Spin, normally all the keywords are errors in the dat section, even if there's been high-level language keywords. So this is actually unambiguous.
Okay, let me catch up with your thinking. So you're saying that we're essentially moving the spin if, except for in spin it doesn't, it's just indentation, and so there's no terminator to the if. And so it's slightly different.
Yeah, it's slightly different. It needs a terminator in the dat section.
Right. This is a non-indention if with a terminator and the complex else directives.
Chip, can the ditto concept be used in code? Like if I wanted to make something repeat 100 times, like to manually enroll a loop, would you want to make this ditto concept be in code too? In which case, it would be better to make this something that's unambiguous that works in code as well as that. Like you're talking about like a ditto, just like making a table.
You have the repeat for that, don't you?
But is it unrolled? Is it an unrolled loop?
Should we make dittos nestable?
Oh my gosh, people, too many subjects at once.
Quadratic explosion.
Let's kind of identify each subject outcome. Keep
One
track
at a
of
time.
subjects, but let's identify it. Okay, hold on, notes here. Now, what do you mean by unrolled?
Like, for example, I mean, if I just in a simple C code or something, or I would just make a for loop, but tell the compiler maximum optimization, and it can see that it's a constant size loop. It will just put the you know, the content of the loop.
In line if
Yeah, in line.
Trade-off,
So
if the runtime trade-off is right.
right, which is kind of your ditto concept, but for code, right? So instead of multiplying a dat section, you can multiply code manually if I wanted to write an optimization.
You know, the repeat instruction actually does that with zero overhead.
Okay. Oh yeah, right. I guess, yeah, because you have an optimization.
It's
concept
like a
that.
hardware thing, yeah.
But you do get sometimes there's a benefit to the unrolled loop, but not to the point where you'd unroll it more times than you can easily copy paste.
Yeah, it depends on whether it's in hub or cog, right?
Right.
Yeah, it's, I mean, the memory is more expensive than the cycles in generally.
Right.
And when
So
the
this is
cycles
an-
are expensive, you often have to, I mean, the main reason for unrolling is just because the old instructions take another 2 cycles to sort of index into memory. And that's nasty. So that's actually the main reason to unroll anything.
So the whole set of commands for this kind of conditional assembly business would be if, else, and end. That'd be everything, right?
Yeah, there's also else if not and if not. I don't think FlepSpin even has them.
Oh, so yeah, we could do if not. You could always if not is kind of like a shortcut to changing
Yeah, if not.
expression.
Well, on
Okay, so we'll
the
say
thing
else
is with
if
the
not.
original Spin compiler, not sure what the Spin 2 compiler does, but it actually does like the 1 bytecode if you do if not, and it does the separate if and not bytecodes if you do if and then not with a space as an operator. That's something I've figured out one of those days.
I think technically, I think if I'm thinking about the highlighting, I think it's not a terrible deal. I just have to open up if and end availability in DAT. Currently, I think I have that blocked from DAT sections. And so potentially this in the highlighter, it's not a big issue for me. And so if everybody's happy with the language, I might be able to accommodate it pretty well. And again, this will be version specific, right?
This is generally unambiguous. Like this would cause a syntax error in compilers that don't support it. So you don't actually have to make it versioned.
But it would, well,
okay.
I'm trying to catch up with your reasoning there.
You can't have a label that's an if. So if you had if
There's no code,
just
so there's no code today that would break once we
exactly
enable a feature.
Right.
Okay.
That's okay. Well, that's gosh, I just worked out all the logic to do that with the preprocessor. So to add that brain stuff into the DAT processor wouldn't be a big deal. I also like the idea of having DAT, the ditto thing, handle 0, because that would enable some cool stuff too. You could,
yes, that's good too. Write it down.
I got it written down here.
What does it enable? It just hides the entire section?
Yeah.
Okay.
If ditto 0, it just chases to the ditto end or the text end of file or another block name first, and then it aborts.
Yeah.
But yeah, that'd be easy to do. That's cool. That's a good idea.
And I'm guessing you repeat 0 also already does that. It does. I remember that code.
Yeah.
Remember chasing through that mentally as you were teaching me.
Oh, repeat 0. Yeah. There's some stuff like, I don't know if I do dead code generation like that in the compiler yet. It'd be easy to add. If you have a compile time certainty that the if is always going to be false. That's an easy thing to not. I mean, it's certain that you can kill some code that way and just not include it.
Right.
Question.
Mm-hmm.
Is this going to make it confusing for some of the beginning users having a keyword like if that has two essentially major structural
Yes.
difference?
This is what Steven and I talked about, because I had used the word repeat instead of ditto. And I thought, Steven's gonna have an issue with this. So I called him up and certainly, he's like, no, don't do that, because that's means something different at compile time. But yeah, then we would be introducing another. I mean, I don't know how we can get around if, else if, because those shouldn't be any more complex than those words. But DAT stuff, the user would just have to understand that any of that business going on in DAT is compile time only. It can't be runtime.
Correct.
I think that's, I mean, if you're starting to write assembly in there, it's certainly an understanding. If you're competent enough to write assembly, then you probably understand that. But if you're using it for that actual data, then maybe you'll run into an interesting. But maybe you can just say if in that must be constant expression when it comes up.
Now, yeah, Francis, to your point, it's not uncommon that when we're teaching languages, we're going to teach foundational elements first and then teach more advanced. And so I can't imagine that these ifs in that would come up early as you're learning.
Not right, they wouldn't. Right. Yep. It's like a video game where they start you out just learning how to like move your character around, and then they add things later on that you can do, and then you kind of integrate that in order, and it all makes sense.
Well, a concern I'm having is if somebody presents a snippet of code, how do you?
They better have the data.
What they're really showing you.
Yeah, consider the audience before you present.
Yeah, if they had the word DAT, if it was a DAT block, if they could show the DAT in there, then they would know, oh, this is a DAT block.
Right. I'm just concerned not everyone's that efficient, or well, not the word efficient, but anyway, complete. So I'm just bringing it up that it can cause some confusion to some.
Yeah.
Well,
normally I'm totally with you, but this one's actually straightforward enough. The way Ada's presented it, that I'm not having much issues with this. It's an advanced concept. There are a number of advanced concepts in Spin, and they turn out to be really, it's those features that make the advanced concepts that make the P2 really attractive to us. Because we can do more of the natural embedded things that we would do in other processors. And so this feels like a natural language growth.
Well, Stephen, do you
honestly, I like Spin just because it's like not annoying.
Yeah.
Like it has a very low annoyance level for certain things.
Chip,
you just kind of plop the file and it works. Yeah.
There's no typecast cops running around.
Yeah. Or issues it's getting the hardware to work than with the language. Although I have built a system, Chip, you and I are going to be working with similar to the one you just solved with table limits. So we'll be talking about that in another day.
Okay. Stephen, what do you think about going back to the word repeat then?
No, because that's repeat in your present form does not, well, it does without thinking.
Well, neither does if-def. You see the conflict, right?
Oh, hold on. No, I don't see the conflict. Hold on. Let me finish.
I mean, if not, if we're going to have compile time if and if not in DAT blocks, which are runtime in Spin method blocks, then it
they don't have to be runtime in a Spin method block. If it's a constant in a Spin method, you can also just prune the part that doesn't get executed.
Right.
I'm kind of, I can see both sides. In one sense, the keyword repeat is available, and it's a little bit makes more sense than ditto. On the other hand, there is a rep instruction, which is awfully similar to repeat, and
Right.
that could lead to confusion.
Yeah, I love ditto. I love that word.
Yeah, that's
like-
just a funny word. You need to add more funny things. Spin
You
2
need-
got rid of some of the spin 1 funnies. We need to add some more funnies in.
Yeah.
happy
Like
with-
when the operator that you think is like the equals greater than or something is actually like an assignment.
To finish my other
Very
thought,
fun.
Yeah. To finish my other thought, repeat has no implied variables that you use. They're all explicitly defined. Ditto has an implied variable of dollar.
Yeah, it does.
Double dollar sign. And so that's why I like them being different. That's the fundamental reason.
You know, if I can make dittos nestable, because you know the dollar sign, that's the little inner loop index value that runs from 0 to the count -1 with each iteration.
Yes.
We could have, for nested, we could have dollar sign, like 0, $1. If you want to put a digit after it, it means that level of index.
Oh boy.
And it's just a
Is the
simple way to do it.
complication worth it?
Yeah, I'm not sure I'd call that a simple thing, Jeff.
No, that's not
Okay,
simple.
well, I mean, do we really ever need nested dittos? That's kind of like making geometric amounts of, well, it's making 2 axes of code that are going to take a lot of space.
Not really. And a lot of the like code that I generate is like more complex than that to begin with. So if you need the complication, you probably are just better off writing a script and pasting it into your file.
Right. Okay, all right. That's good. So we'll leave ditto. I'll make it sensitive to 0, and then I'll look into adding the dat if else business,
Right.
and so that we can have compile time variable dat blocks.
And with the language highlighting, I'm very close. I have to put out a couple fixes. Thank you, Ada, for reporting issues for me. And I'll try and kick in the language keywords, adjust the tables and get version-specific language keywords in there. There's additional coloring we want to do, but I'll work with just the keywords for now for the next release of the Spin extension. I fixed a couple parsing issues too, so there are less crashes.
Cool.
Another one coming. I've been remiss in putting out rapid versions, but that's probably good for everybody.
Yeah.
So you were going to show the logic bit fields.
Wait, logic bit fields.
Multiple bits and a name
Wait, multiple bits in a name.
for the logic display. That's why you have.
Oh, yeah, but I don't know. Okay, I don't know where I put that file. Okay, wait, I know where to find it. Just takes me a second. Because it's kind of a cool feature. So let me look in my thing here. And let's see. I know I called it something, but I can go grab it. Let me get it out of this other
Are you
thing.
watching Motors with this?
Say what?
You must be watching Motors or something with this.
Yeah. I'm going to show you guys something that I've been working on that I think is just super cool, and it kind of surprised me. Just what but it's anyway. I'll get there in a minute. Let me see if I can find. Oh, so much data. We're just drowning in directories and junk. Net B40.
Every one of those has a pile of folders and projects.
Oh, here we go. Okay, I think I got it in here. Wait a minute. Okay, what did I call this thing? It was the debug. Hard to think under pressure. I'm looking here. Will I not have it? It would have been a spin2 file. Oh, here it is. No, that's not it. No, I guess I don't have it. I put it on the forum though. But anyway, it just suffices to say that you can now have data aligned waveforms that are both binary and analog. so that you can like, because what I've been working on this quadrature amplitude modulation transceiver for RF over pins. And I needed to instrument it because I have here my scope, I have a multi-signal oscilloscope, I've got these other things, but I realized, wait, I can totally instrument this using debug statements where then anyone who gets the program can run it and see what's happening, right? Without needing my whole test setup. And so that's why I added this business where I needed to be able to see binary states plus like multi-bit waveform states all time aligned on the debug display, so you can, track the coincidence of phenomena that are important. Anyway, we'll have stuff about that in the future. Okay, so I won't worry about any more of that at the moment. Let me close this down.
Did you put it in the forum? Do you think it was in the compiler thread?
Yeah, it's
Oh, there it is. Hold on.
It's called.
Yeah, you've got it here.
Called plot
it's
range
a post data,
demo.
Yeah, it's a post dated January 18th in the Peanut thread. Can I do? How do you do link?
If you can paste the. Let's see. Why am I'm looking here? I don't see it here.
How do I do a thread link?
Wait a minute. What directory am I even in here?
There it is.
Oh wait, I'm off in the weeds here. No, I'm right. Okay. Yeah, I don't know what I called it.
No, that's not it. I'll just copy it.
Are you saying, if you can even just, can you get it on your screen and then you share your screen and just show the plot? Okay, I'm going to stop sharing. So Stephen, you grab it and then.
So I'm just looking in forums and pull it up. Should look a lot like this.
There it is. Yes. Yeah. So this was all. So the plot, the logic display in the plot window receives like up to 32-bit values, and so this will let you break that 32-bit value down into like there's 8 bits of something called low, and then there's 2 that's an analog waveform. There's 2 bits of binary called mid, then 4 bits of binary called high. Then there's D, which is 4 bits of analog, and so it just takes that data and displays it, breaking it out into single bits and multi-bit waveforms. So you can now instrument things and see like everything time aligned that's matterful.
What's kind of scary to me. Who remembers on Unix the old typesetting tools? What was it called?
On TR or trough?
Yes, trough. I was doing a multitasker in 1989, cooperative tasker using an embedded system, and I'd write the task ID out to unused address lines. My logic analyzer would be sitting there pulling that information and capturing the waveform, kind of like you see the top gray. And I'd capture it and feed that stuff into trough to generate the output logic displays. So in 1989, I was generating this kind of display using our high tech and following my multitasker and when it was switching tasks. So this kind of scares me, but it's pretty cool.
Well, see, it's also
using a lot fewer tools to produce this than I was.
It's staircase stepping too, because I didn't want to connect lines because I wanted you to see where the data were.
Right.
So you can see where each step is and line it up with every bit.
It's kind of showing you the bus value at that point in time.
What I got to do is I got to make a special cursor for the logic window so that when you're in there, you just have like the cursor is a like screen length vertical line, like a little dotted line so that you can see, you can check coincidence of things.
Yes, yes.
Right now it's like a little ambiguous, but you
And
probably won't be looking at such dense data.
The value over the bus you're over too, simultaneously.
Oh yeah, yes. Okay, there's more work to do.
Chip, if you're going to be working on cursor flags, is there a way to adjust the XY cursor stuff in the crop window, that little, I'm always, maybe it's just that I'm old. I have to grab a magnifying glass to read that thing because it's small and it's kind of darkish text on a dark background. So it's really tricky to see.
Yeah, you know, okay, the fast way to solve that problem is make your text big in P2, and then when you run it, the text will be big in the window.
But what
It's a stupid way to do it, but you see,
it could blow up every other display. If I'm using text all over the place and a display, then that would screw things up.
Well, it's
all right. I have other ways to around the problem.
Well, each display has its own text size, John.
Pardon?
Each display has its own text size, right? Each display window.
Well, I'm talking about in the crop window. I normally turn it off, but when I'm checking things, it'd be useful to know what the P2 thinks I'm hovering over. I'll figure out another way.
Okay.
On the getting back to earlier, you were talking about stuff with the structures. I had trouble. I started experimenting with them, and I have a structure with 4 longs in it, and so I was trying to pre-assign it with, you know, structure variable equals A comma B comma C comma D.
Some bug crept into the compiler that I got to fix.
Okay, so yeah, I just wanted to remind you of that.
Yeah, no, I know. Yeah,
if I assign the individual elements, it works fine, but the single line, you know, multi-variable assignment didn't.
Right. Okay. Oh, let me go make this small again. So that's how you make it big. Do this and the cursor becomes big in the debug display. All right, so
that's intriguing.
My friend Doug
does
all this
sorry.
automation development, and he wants something that can control motors. So he asked me to write some code for him to use the P2, and he's thinking, okay, he's visualizing it like we can have one cog to control each motor. I thought, well, yeah, we could do it that way, but we could get a lot more out of a cog than that. So, because if you think about, what he wants to control are motors which receive a pulse with a coincident up-down state, right? So there's 2 wires. The direction wire is, you know, let's say 0 for forward and 1 for reverse. And then anytime the step wire goes high from low, that's a motor pulse, right? So you run the motor by pulsing it with direction signals. And of course, you never really turn the direction around until the motor stopped. Anyway, so I was thinking about this problem, and I know that in the future, he's going to want to run a heck of a lot more than 1 or 8 cog motors for that matter. So I thought, what can we do? What can we exploit in the P2 to be able to run lots of motors at once? And I realized, well, we have this like NCO smart pin mode, right? Where on every single system clock, a 32-bit frequency gets added into a 32-bit accumulator, and the MSB of that is output right to a pin. Okay, so this is a free running thing. You set it up and it just runs. It's just continually integrating and outputting the MSB. So it's like, okay, well, that's cool. That takes care of that. I mean, that in theory could take care of the step signal generation, right? Just a free running NCO. But wait a minute, there's a huge issue here. How in the world do we know where that thing's at, right? I mean, it's free running. But what I figured is by making a loop, a motor control loop that is some power of 2 in clock cycles, we can easily do a super integration. Because if let's say you're doing the loop every 2 to the 10th clocks, well, you know that thing's integrated 1024 or 400 hex times, or basically just shifted up. How many bits is that? 11. So, or 12 or 10. So it means that it is very practical to integrate separately the behavior of the NCO that's driving a pin. Okay, so I've been playing around with this thing here, you know, our buddy Chat GPT, right? And it's just so amazing. I mean, I start off asking it some questions about motion control because I wasn't really so, up to date on everything. And I asked it like, well, what are typical like loop computation times? And it says, the outermost loop, the position loop, is typically 50 to 1 kilohertz on the high end. So I figured, okay, well, what if I make like a millisecond loop, which is actually a power of 2 division of the main clock frequency. Like, let's say we make the main clock 256 megahertz and we divide that by 2 to the 14th power, right? So we get roughly a loop every 1 millisecond, which is like an eternity in machine time, right? So I figured, okay, so at 1 millisecond intervals, we'll change the recipe, right? We'll change what's going on and what we're feeding into the whole system. So let me run this thing again. So Chat GPT explained to me, how, gosh, I have this banner. Let me see if I can move away. Okay. So it explained to me about, it reminded me, you've got position, and then you've got the first derivative of position is velocity. The next derivative is acceleration. Next derivative is jerk, which is change in acceleration. And then you've got further derivatives they call snap, crackle, and pop. And they say that if you can control everything at the snap basis, using like constant snap, you can really minimize all kinds of forces that tend to wear out machines and cause too much energy to be expended while they move around. Okay, well, I've built this thing up so far with constant jerk. So here's the input to the motor control, right? Is this simple jerk thing. And so in this deal right here, I have it just, my jerk value is 1. So at these intervals of 1 millisecond, I can change the recipe for how I'm driving this thing. So but you have goals, right? You got to move the motor from A to B. And you just can't do that instantaneously by doing an add to position. You've got to slowly accelerate it, get it to the midpoint, or maybe you hit your velocity limit and then you carry it over, and then you got to figure out how to land the airplane at the end and get it so that it comes to a complete stop right where you want it, which involves a little bit of calculus, but nothing too serious. ChatGPT briefed me on that. And I only went to high school, so I don't understand all this, summations stuff in calculus notation. So I just had it write basic code for me, and I can understand that, right? So let me pull that up. Where's that? So, it tells me like, here are formulae for, jerk through position. And I'm, okay, no, this is where I lose it. I don't know what that means exactly. I can, in retrospect, figure it out, but it just will, show me like, oh, great. Now I can totally understand this, right? This makes sense. It's digestible. Now I can go back and look at that and figure out why that does what it does. But I don't know those things. Anyway, so this is really cool. This GPT, it's become like, a whatever level textbook you need on demand. I mean, look, it formats all this stuff just based on my queries. It even writes code for me and explains why it works. So then I kind of get interactive with it and say, well, I've got these resources. How can I use those? And it gives me like lots of ideas. And anyway, it's been really helpful. It's just so amazing that some of this knowledge, which was once arcane, is now you just find your way into it with some simple queries, and you can go wherever you want with it. And this thing's so awesome, it just, anyway, so this is.
I would like to caution you though, Chip, that it doesn't understand anything. So it's.
I know exactly. And I know
Yeah.
Ada hates this thing. I get it. I understand all that.
It's a useful tool, but just know the limitations.
I know. What I see it as is a resynthesizer of human knowledge, right? It takes everything extant, and now you can have it, ultimately it'll be able to, maybe it'll be creative too, but in some fashion, but at least it can like resynthesize knowledge and give you what you need out of the knowledge base without you having to know everything. Like it used to be, you had to figure out, well, I need some knowledge. What is the keyword? Like, we had this thing at Parallax that ground chips once. I could not find the name for what are these commercial grinders that just grind stuff into dust. I had to figure out slowly. It took a long time. There's this term granulator. So there are these machines called granulators that do this grinding. Well, you know, this thing will get you in the ballpark in the term granulator right away without having to know anything. So anyway, it shows me here, like here's the, you know, if you need to do if you want to figure out how many iterations, you know, you can, this is great. I mean, this is important here, right?
Well, that's exactly the kind of thing though where you need to check it because
yeah. To Eric's point, the truth is using this material as is without auditing it to prove that it's behaving correctly is just an incorrect choice.
The audit is, I know, but you know, the audit, what I'm doing is not that complex. The audit comes in the form of, all right, I'll implement it and see what it does. Well, it is working like advertised, so that's good knowledge. It's usable.
Okay.
But I mean, it can take all this like algebraic, you know, manipulation and reduction and come up with this. It's like,
part of the bigger problem is that you lose the like provenance of the information. Like where does this come from?
Yes.
It just comes from the
that's
neural network weight soup.
No,
like you don't know who came up with it, why it is like that. It just kind of comes out like that.
It's parts per billion in the soup, origin unknown.
No, that's
probably they pirated some sort of textbook and put it in there and did it illegally, but then they like killed a whistleblower. Like they literally did that. Very interesting.
One of the things I found, Ada, too, is that depending on which interface I use, talk ChatGPT versus Perplexity, for instance. Perplexity is taking the angle that they give you all the references possible for things they've found. And so that helps a little bit towards what you're saying.
I know this is no panacea, but I mean, it does have its usefulness. So it was very helpful to me to kind of like jump in without having to do a lot of strenuous, you know, digging around for information. It just kind of got me in the ballpark right away, and I could even run things past it, and it'll say yay or nay, or yeah, I could see, you know, it could. It's kind of like it's like someone who may not know everything right, but they know a lot of stuff, and they're just free. They're available to ask questions, and you got to, of course, check the veracity or prove it, but whatever. I mean, at least it does have a lot of utility. I found it useful. So it got me up on like, you know, what are the equations for like, well, there's that, you know, there's something that was important. And then, oh, here's that crazy, you know, cube root. It's like the third integration of jerk is position. So if you want to know how many iterations, you've got to take the cube root of the distance divided by the jerk. And so I was able to use, you know, everything's cool. When you get numbers into log form, you can do fun stuff with them. Like you can take a log of a number, divide it by 3, turn it back into a number, and then you've got the cube root. So it's like, so I have this in the Cortex solver in the hardware, right? It's just there. So this lets me, you know, determine cube root without staying in fixed point. Well, I don't have to resort to floating point. This is a problem. I only got like 18 bits of usable data in here, but I'm going to fix that. I'm like, you know, 32 bits is enough for any kind of granularity we need, except when it comes to overall position tracking, because we're dealing with, oh, I see you, Stephen, such deep integrations. But anyway, so I run this thing again. Okay, let me just run this again. So here we have everything is controlled from jerk. So imagine jerk is like, I see you later, Logan. Or were you waving bye to Stephen? Okay. So jerk is like this little toggle switch that can go. It's like a return to center switch, right? You can push it up for a while, let go, it goes back to 0. You can push it down. And so the crazy thing is that in the big picture, you got to like take an airplane off the runway, fly it over a bunch of ground, and then land it where the nose cone comes to a smooth stop where your velocity and acceleration are at 0. And you got to like pre-compute all this for your motion path. And all you're going to be doing is twiddling this little switch up and down, you know, with some constant injection of jerk. Now I might make this later, so I do constant injection of snap, right? And then the jerk would look like what the acceleration looks like here. And then the acceleration would look like the velocity here. And then this would be imperceptibly different, but it would be actually better because there would be like lower strain forces on things as it went through all of its business. So I've got this little thing now, can do like 16 motors, right? So if you have like 32 IO pins and you've got pairs of, you've got the, say here's 2 pins. One is the step and the other is the direction, which can be high or low, right? As the cycle goes. So this is really cool because it totally unburdened the cog. Now the cog, instead of having to be Johnny on the spot where it needs to start a pulse right on the cycle nose, or you're going to have to suffer a little bit of short-term jitter while you fly through your list of who needs to start a pulse. Now the NCO runs it totally quietly in the background, and the cog only needs to intervene every 256,000 clocks. And so there's a problem though about landing the airplane exactly at the point, is that when you have 1 millisecond control period, you can only change your jerk every 1 millisecond. There's some, you're going to under or overshoot your goal, right? You can't really avoid it because your timing granularity is very coarse compared to the position granularity you need to achieve. So I was like racking my brain, like, man, maybe I can like compute some adder value for the NCO when it's not 0. But that I did, everything was failing. And I finally had this idea, well, wait a minute, I can compute the whole course and then I can look. You see, the problem is that we only have like low granularity when we can make our adjustments, but we got to have super high granularity on the finish position. So I realized, well, wait a minute, maybe I can compute using frac like a, let's see, where did I do that? Right here, this is all it took. I can come up with like an NCO scale value. So no matter what the NCO value is, I'm constantly scaling it by a really high quality 32-bit number. And it's going to adjust, this allows for like upward or downward adjustment, right? Ever so slightly. So then I can like land the plane perfectly right on the spot. So I made, okay, we're going to run this thing again. So what I did is, you know, we have 2 adjacent pins. There's step and direction, right? Step and direction. So the direction pin is really dumb. It just changes, you know, when the motor direction changes, it'll toggle. But it's not doing anything otherwise. So I go, okay, I'll put that in the totalizer, a totalizer count smart pin mode. So it's going to count the pin down from it, the cycle pin, which is going like this, and it's going to increment the totalizer if the direction's higher. It's going to decrement it if it's low. So now it keeps like faithful accounting without taking any other IO pins. So I got 1 pin as an NCO, 1 pin is like an up-down totalizer using step and direction and inputs that are right there. And the top line you see here is the totalizer. It's dark blue, so it's hard to see. Oh, you know what? I might have some crazy, let me see here, hold on. I got to turn off my.
It doesn't look bad here.
Okay, well, I got to, okay, yeah, that dark blue is really kind of too much. I have a blue light inhibitor, so sometimes it makes blues hard to see. Anyway, so the totalizer is up on top. You can't see that number, but it totally matches. So now I have like numeric and count agreement between, you know, the effort. So I know that the math is good because it's actually showing that, you know, the actual number of pulses in the given direction were just right on. Anyway, so I'm going to just briefly go over this. Some of you guys already see what's happening here, but this is jerk, right? I can change the jerk recipe every millisecond. But I use constant jerk so I can do nice integral equations. Well, no, actually, I could be, if I broke those equations down, I could be changing the jerk along the way. But it is nice to just do one computation and get an integral of what our position is going to be after the application of so much jerk. So here you see when jerk is neutral, when it's 0 here, well, it's not adding to the acceleration. So the velocity is not changing. And because the velocity is at 0 to begin with, the position is not changing. But then as we start applying jerk, it starts ramping up. So every time, every millisecond, jerk adds into acceleration. So as long as jerk is high, acceleration climbs. Well, then what we're going to do is we're going to drive jerk. Well, so this gets us to the midway point. No, actually, it gets us to our mid acceleration point, or actually the peak of acceleration. Is that right? Yeah, the peak of acceleration. Well, no, acceleration's constant, right? It's just moving. No, it's varying, but the first derivative is like it's like a square wave. Anyway, we drive up. When we turn this thing around right here, we're only 1/6 the way up. And if you run that, you know, fourth derivative equation, you're dividing by 6 over. So it kind of all makes sense, right? So what we do is we drive acceleration up, and then this at every millisecond, the acceleration is adding into the velocity, which is updating the smart pin, and we're accumulating it in a separate accumulator. But we're super accumulating it at a 14-bit higher position because our what can I say? Our 1 millisecond is really 256,000 clocks. And but what we're really doing is we're getting our number, our integral count number all the way above time-wise the MSB of the NCO, right? So when the NCO rolls all the way over, that's a position count to us. So by arranging the bit fields, we can do this. Anyway, so we have here jerk accumulating and integrating over time into acceleration, which integrates into velocity, right? Now you see there's nothing jerky apparently about the velocity. And then that integrates into position. So the velocity goes up, then it goes down back to 0, and now we're at a new position ending with velocity and acceleration both 0, just by applying jerk, like, you know, 4 derivatives back, or 3 derivatives back. So anyway, I was really happy about this because it was a way to like control these step and direction motors without completely unloading the cog. You know, the cog only has to do anything at a millisecond, and I'll show you here. This loop, this is like the whole thing. Okay, this is it. So I'm using the ditto thing here to like replicate these pins here. So what I do is we do an add count, we wait for the time marker, and then we go boom, boom, all of our however many pins up to 16. We look at the sign of our NCO, which is really our velocity, and then we set the drive pin. Is the drive pin going to be up or down? And then we update the NCO, right? All on schedule, right on the crystal clock edge that matters. And then we read the totalizer just to update our little base down here of variables that are tracking everything. And so that's like the part of the business part that's actually handling the hardware. And then down here we go, is it time for a new command? Right? Because that bottom thing you were seeing here, this is just the command counter, right? So we say do this for so long. So you're seeing on the green, you're seeing the counter roll down. And when that thing runs to 0, it gets the next command. That's what that thing's about. It's not really anything to do with motion. It's just timing the commands. Anyway, so we do all the command logic here, you know, and then we go and get a command, and we set here we set like the cycle count, the jerk, the tweak factor, and then we increment our tail for the command pointer. And then here's the part that does all the math, right? So we go, okay, integrate jerk into acceleration, integrate acceleration into velocity. And now here we do the tweaking, where we take that big tweak value that gets us around our time granular constraint that doesn't give us exactly what we want, and we just tweak the NCO value slightly. Then we get it back into sine form, and then we set that freak value, which gets used up here, goes into the smart pin on this right Y pin. Whoops, second one. And then we sum it into our position. We do the position. We update the position low and position long. So we're tracking position to 64 bits. Because when you're doing this integral stuff, your numbers grow real big. You know, I mean, if you're integrating 4 levels deep, your number expansion just gets huge. Anyway, so this is my shiny new toy that I made.
I have a question, Chip.
Yes.
So if you zoom out, like what is you're obviously driving a stepper motor, right?
Yes.
Without an encoder because you're letting the P2 do it. So what's between the P2 and the stepper motor, the amplifier?
Oh yeah. So he's buying these motors from China,
Okay.
which take a step and direction signal. And I'm sure internally they have their own PID loop, which is trying to make it all work.
Right.
So, I mean, you could build a stepper motor driver circuit that would take the step and direction signal and run steppers. But in this case, these motors are kind of cool because, the problem with the running these motors is you got high currents, right? And then if you have long wiring, you got big inductive problems. You got giant, it's like the voltage and currents are whipping all over the place, and it's not. So these motors, they take in like 24 volts DC, and all at the load point, they do all this, the power signaling, right?
Right.
They don't run, so what the power supply wires see is like changing current draw, but no crazy voltages, no inductive flybacks, nothing that's going to disturb anything or cause anyone heartache.
Right.
So the motor's handling it. We just have to give it the step and direction.
Okay.
See this here? This is like a bunch of movements, right? Let me turn my scope on. I got to show you what this actually looks like as it plays out. Let me run it again. Okay, let me get the scope timing all set right so we can see a picture here. Now, I could have instrumented this, but I didn't. Okay. All right, one more time here and I'll have it. There we go. Okay, so, all right, now I'm going to move the camera here. Can you see my camera? I can turn my, I can stop sharing now. I've shared. Okay, so can you see the scope? Oh, it looks terrible. I don't know if I can like meaningfully change my intensities. It's not having any effect. I'll try to make the camera stable at least. Okay, so you see there, these are 2 pins, right? That's so bad. I don't know what I can do to make it any better. Anyway, we're just gonna have to live with it. Let me try to set this up right.
We can see it pretty good.
Okay, yeah, I don't think I can make the signals any taller, but okay, so what you have here is this is the direction signal, right? That smart pin is actually acting as a totalizer as well, but it's a pass-through for the output state. So we run that as the direction signal. Down here are the step signals, right? So watch this. We'll zoom in on this little guy, right? And everything just worked out so beautifully. I did have to add for my very initial NCO value, because with a smart pin, you can start up the NCO with a certain phase. I put it at 4 bazillion, right? Which is halfway between when it's going to roll over and when it's going to roll under, because I wanted to get that step transition point beginning numerics. I don't want it to like have a coincident, anything nearly like a coincident direction and step change. So I moved it out of the way. So anyway, so you can see here that here it like says, okay, now we're going to go the other direction. The motor stopped. See down here, and then we go, okay, here we go. So go this direction, and it goes boom, and lands right there. Like the exact number of pulses that we wanted, and then here it runs the other way. And then so I'm going to for Doug, I'm going to add a lot of stuff to this so we can like start the motor jogging. We can then give it different endpoint parameters for like jerk and acceleration limit and velocity limit for either endpoint, or let it free run. And then if we hit a limit switch or a waypoint, then we'll stop it. And eventually I'm going to have to add some stuff into it so I can drive through waypoints with like certain velocities and even maybe accelerations, right? So if you're using this motor control thing for like an XY gantry system, it's not just about getting from A to B like a one-dimensional conveyor belt on a machine. It's about coordinating with another motor. So that's going to be some added stuff I'm going to have to do. And it'll probably get a little closer in than what I'm doing now. But anyway, I got to augment this thing quite a bit for that. But it's really no big deal. Once we get this basis stuff in place, it's easy to do the rest of it. All right, I'll put this thing back where it belongs. And then just one last thing, I'll just share again here real quick. Let's see. Okay, so you can see here, by driving jerk, it created these accelerations, this velocity profile, and then this position profile. So the motor moved one way, and then it moved the other, coming back to home. Then it moved out again, moved the other way. And then in the code, it was just these like 4 instructions here. So I gave it where I want to go and what my jerk is, and it just drove the motor to there. All right, that's that.
That's awesome.
Yeah.
The thing about
That's
the... Oh, go ahead, right?
Yeah, that's the right way to go.
Yeah, well, yeah, I'm glad Rainer's here because motor control is his whole thing. That's what he's been working on since I've known him, is motion control.
Maybe I can show you something that somehow is related.
Please.
That somehow is related. Let me check if I can change. If you will. So, okay.
While you're looking that up, my initial errors before I added that tweak, that overall 32-bit tweak, they were sometimes over 1%, because you just don't, when you can only control things at millisecond intervals, you can't get exactly where you want to be. You got to you're going to wind up maybe close, but not close enough. So that tweaker thing fixed it. But you know what? That's not going to work for real-time coordinated motion control, because both motors have to be acting in perfect. One A has to be at where he needs to be at the same point. B needs to be where he needs to be. If you're going to, like on X and Y, draw a perfect circle, you can't have any so I'm going to have to, come up with something different for that. Maybe I don't know, I'll get there when I get there. But for just moving perfectly from point A to point B, this little scheme worked just right on. And you can see there's hardly any code to it.
So what do you think the resolution is the way you currently have it?
I don't know. I mean, I'm tracking position to 64 bits, but I'm not doing 64-bit math yet. So that's what I need to do. Is I ultimately, when I do that cube root for the derivative, I need to take a 64-bit number and get a cube root out of that. That's definitely going to fit in 32 bits. But I'm going to have to do some, I can't just use existing commands. I'm probably going to have to do some inline PASM or something to use the Cordic thing to help me out with that. Or maybe I can figure out that I want to do some, checking on how can I slide bit fields around and do computation with in-range bits and then expand them out to their bigger positions later on. There's all kinds of, communicative laws you can exploit. I just got to figure out what they are in this area of log and stuff. All right, Rainer, sorry.
Okay, yeah. So, okay. So, what can you see? Can you see my screen now?
Oh, I see what looks like maybe some electromagnets with a bolt.
Okay. So, this is a motor, and indeed there's the motor is now you will see it is running. And okay, so the motor, you see the front of the motor, and there's a bolt, Yeah, you see the cursor?
Yep.
Yeah, okay, there's a bolt, and the bolt is just fixed with a little bit of tape here. And over here, you see a magnet.
Yep.
And this magnet is ranged a little above the path of the bolt. So let me run the motor. So, and now you see the bolt comes.
Wait, okay, so it's turning.
It's turning, and now it arrives to the magnet. At the moment when it arrives the magnet, then there is a jerk.
Right, there's a sudden change in velocity.
Yeah, but then you see the actual movement only happens later. So here the action comes, and then in this place,
oh, it jumped out.
It reaches the top. Yeah.
What's the bolt doing?
So that is exactly what you described in your. That is exactly what you described, because you set a momentum, a pulse, to the inertia of the screw of the bolt, and so the movement of the bolt is determined in this moment. Everything else just happens. Once again, yeah.
Are these indicators, or is it acting like some sort of governor, or what?
No, it is. I wanted to have a small force acting on the motor. So what you actually can see. So this is just.
But you're doing this because this is like a phenomena that occurs in all motors, and you've made a test jig here to be able to work with the principle, right?
Yeah, it is. When the motor runs at a given speed, and there's always a balance between the driving force and the braking force. So if there's a little additional load, then
it's an angular load, is what you're saying.
Yeah, when there's a little angular load, then the motor will be slowed down a little bit.
Okay.
And the question is, can I detect that there is this event happening? And the answer is yes.
Can you?
So the propeller is able to determine that the motor is slowed down a little bit the moment when the bolt is activated.
So you're checking for like very short-term changes in velocity, right?
Right.
So you have to have some kind of resolution. You must have like some kind of encoder on this motor that you can detect a difference in pulse widths on.
No, that the point is you have to do it without a sensor.
Like this is about field-oriented control, right?
It's the very start. Yes, the very start.
What are you measuring then? Current?
Change of current. So the momentum you have on the mechanical side, you also have to have on the electrical side. And that is what you can see. I can show you another video. Just a moment.
Fascinating.
That's let me see.
Rainer's been working on like field-oriented control for quite a while, so that you can know you can know things about the motor you're driving without actually having any kind of encoders or Hall effect sensors.
Yeah, he's been on that way back when. By the way, are you like, I kind of copped your like eval board, and now they don't make them anymore. I'm here to say sorry.
Sorry, I could not follow. I just was.
I
Can you
kind of
repeat?
like, I kind of took your eval board and now they don't make new ones. I'm kind of sorry.
I have my own hardware, and what I show you to what I show now is everything is running on a P1, on a Propeller 1, and I'm now moving this to the P2. That is why I just started to actively work with the P2, and I have, yeah, I have to catch up with all those developments over the last years. Okay, so here you see this is a screen where I can show an internal value, and this is the wheel of a small AC motor. So it's not a stepper; it's an AC motor. Yeah.
Why is there
And
tape around it?
Yeah, just to be able to touch it.
Oh, you mean to provide some resistance or something?
So it's an elastic load. You will see it.
Okay, so you'll squeeze that,
and sometimes when I create yeah, just when I create a quick sample, then I very much like to use tape. I have a lot of tape, so, and I have to make use of it.
it looks
So,
like
okay,
an earwax removal tool.
So here I have a dot. This dot is generated or measured internally by measuring current of the motor. And you see this dot is below this line. And so if I start, you see the moment I break this motor, this dot moves upward.
Yeah.
And when it reaches the positive part, then the motor stalls. So that means when the motor starts, now there's in the very beginning there's too much current for this given speed, for the given load. And when I increase the load, more and more I make use from the current, and then it climbs up and it comes to this point. And when it is in this point, I know this is the optimal point to drive the motor.
Oh, so you're getting the best efficiency for the power being dissipated.
So if the moment I increase the load and I come to the positive part, then I just have to increase the current and it will go down again. So this is actually the reactive current of the motor. So here there is too much reactive current, and when it comes to here, it's okay. And when it exceeds this value, it's too low, and then the motor stalls. So I have a different video. Let me see if I can start it. Maybe I have to start again. Okay, you see it?
Yeah, now why is it moving on the x-axis too now?
Okay.
Oh, it's actually kind of cogging. It's not even turning.
Yes. So I start. Everything is fine. And the moment when I come to the positive part, it starts to vibrate.
This is a stepper, right?
No, it's
a
an
BLDC.
No, it's
brushed motor
magnet, brushless so permanent magnet motor. So it's not a stepper.
So it has brushes.
Without brushes, brushless.
Like the carbon brushes that
No, they are. It's a PMSM, so permanent magnet synchronous motor. Just a normal servo motor.
Permanent magnet. So, but it doesn't use mechanical brushes to deliver.
No. It's just
a brushless DC. brushless
No,
DC
it's an
pen.
AC motor.
Oh,
It's
This
a
is like
synchronous.
what's used on old or my milling machine has this kind of motor on it.
It's a servo motor. It's a servo motor.
Okay. Yeah, because what it does is it spins a magnetic field that the other part tries to keep up with, right?
Yes, yes, yes. So just it is quite a normal synchronous motor with a sinusoidal supply.
Yeah, because these motors want to turn at the AC frequency.
Yes, and
Yeah.
when they stall, they show the same behavior as any motor. So when they stall, it means they are driving in a different direction until it comes to a point where the field is again oriented in the right direction and they start to move forward. So a stalling motor will always vibrate.
Oh, okay, so what you're doing, what that graph is like phase lag between what you're inputting and then what it's consuming.
And, let me show it and stop.
And this is like the original kind
This
of
here,
electrical motor.
That up there.
yeah, what these dots here, they just show that the phase of the motor is going forward and backward. So the mechanical phase of the motor is going forward and backward, while the driving field is going forward with a constant speed.
Yes.
And therefore, the phase angle is always changing between 0 and 360 degrees. And here you can see the phase angle. This definitely is a phase angle. So I can measure what normally is done with field-oriented control is field-oriented control just brings the driving field perpendicular to the motor field, to the mechanical field. Yeah, to the permanent magnet field. This is what is done. And if you change it, you get a signal, and this signal is on this circle. And if you look very carefully, you see here is a second circle. Here,
oh yeah,
circle, yeah, and here's the circle. And this shows two different types of vibration. It is the motor itself with the inertia of the motor generates one vibration. And the elasticity of the tape gives a second vibration. And this can be seen.
Wow.
Yeah, that's definitely. So here now you see it better.
Yeah, it's the field is spinning
you see
around it and it's not keeping up.
Yeah, here you have this first circle, the second circle, and this is just a residual from the very start. And you see that my hand is vibrating and this thing is vibrating. Yeah, so different frequencies. Okay, yeah. So, but
interesting. Now, does this kind of idea extend to brushed DC motors?
This is just.
This requires an AC field.
This is in principle. This is valid for any. This is valid for any motor. A brushed motor. So it may sound strange. Look, we have a certain feeling what electrical current is. So electrical current, let's say you have a DC current, and normally you see the current as there's a positive pole, the positive and the negative wire, and the current flows in one wire. So you say, I measure the current in the positive wire, or you can measure the current in any place of the whole circuit. But you do not see the cable as something that has a positive and a negative wire at once. So if there's a positive wire and a negative wire together, you say, okay, this is in an average current of 0. So every closed loop always shows a net 0 current. And if you have 3 phases, things start to become different, because in one phase you have the current flowing into one direction, and the 2 other phases you have flowing the current in the other direction. But you can say, okay, I have a current of a certain amplitude with a phase angle. Yeah, so you have this square root of 3 thing, and this gives you the amplitude of the current, and it has a certain phase. So now imagine you have a phase angle of 0, then one wire has no current. One wire has a positive current and the other has a negative current. And when there is no current, you do not need a wire. So you have only 2 wires, one with a forward flowing current, the other with a backward flowing current. And if you see it this way, a DC motor is a DC current is an AC current of a fixed angle with a changing amplitude. From a mathematical point, yeah, this is just true. Yeah, it's just true. You have two traces of current, and that's it. Yeah. So if you think about this, then you may have some crazy ideas, and that is very funny. Yeah, but all of this is about how to invest and how to get the money back. So I now can show this because I just filed a patent for this type of motor control, and I hope within 2 months or so I will have a demonstration unit based on the PE2, and that actually will be a breakthrough.
Good. Well, Rahnor, you have my email, right? It's casey@parallax.com. So I'll help you out because there might be you're going to have some questions along the way, and I'll answer them for you. Just email me.
Yeah, I will. There's a reason why I'm here this evening. But it was very funny, very interesting to see what you did with the stepper. So let me switch. How can I switch off here? Whoop. Okay. Okay, so it's what you showed is actually a good idea. It's a cascaded software that actually makes use of the fact that momentum integrates to jerk integrates to momentum integrates to speed integrates to distance. Yeah. And then the integral is stopped or not. So what is if you do the next integration? Yeah. What
is the integration of position? I don't know. What is the integration of distance?
Yeah, that is the that actually is a point. Though this point reflects in physics. You know, when we talk about voltage, then voltage times current is power.
Right.
Power integrated over time is energy.
Right. Right. Yeah, because power is energy over time.
Right. And energy integrated over time.
That's the distance.
No, energy integrated over time is the action.
Okay, but I mean, that's like analogous to integrating distance.
Yeah, right. So you know this term, the quantum of action,
Yeah.
H, the famous, very famous H, yeah?
Quantum
And
of
the quantum of action invented or discovered by Planck. Yeah, the base of all quantum physics.
Oh,
Yeah.
interesting.
Yeah.
I don't
So,
fully understand, but I kind of get the edge of it.
yeah. So this quantum of action, this is by dimension, it's energy times time. So it's the integration of energy over time. That is the quantum of action. But it's hardly understood what it means. So therefore we say it is just a constant.
It's like trying to contemplate superposition or something, and like,
Yeah, it's a very, very interesting question. I'm having on my table since decades, and I have no clue, no answer.
well, no, I know what you're saying. You know, I think because we like in this kind of world or our lives, we're constrained to 3 dimensions, 3 physical dimensions and time. There's stuff that we can't really contemplate because we don't have the facilities to do so. We kind of like can feel the edge of it, but we don't know what's inside.
Yeah. So you see, I'm always on the path to ask stupid questions. So you you know, we have the electrons and the protons, and they are monopoles. Yeah. So we have electrons negative, protons positive. And then we have the magnet. And the magnet is a dipole. So we cannot separate North Pole from South Pole. Whenever we break a magnet, we will have 2 North and South poles. Yeah.
Right.
But why do we say we have 2 types of electrical charge? It is, we have electrons and they repel each other.
Yep. We could have a depletion of electrons or a excess of electrons, creating either charge.
Yeah, but imagine you only have 2 electrons. You only have 2 electrons, and when you bring them together, you feel a repelling force.
Yeah.
Yeah. So now you have 2 protons. You bring them together, and you feel a repelling force.
But you know, how is it that protons are glued together in nuclei and they don't come apart? Is the neutron, well, a hydrogen just has 1 proton. Right?
That's the strong atomic force that pulls them together.
Right. So it has a name, and it has a name.
Does it only work over short distances or something?
Yes. But let me come to another point, and you may understand this. You may find an answer to this question. If you have 2 protons, you bring them together, they repel each other. And from the experiment, you cannot decide if you have a proton or electron.
Oh, if you're just measuring force.
If I give you an experiment where you measure the force, you cannot know if these are electrons or protons. Only when you have a proton and an electron together, then they will attract. And and now you define one of those as a proton and one as the electron, and it's just because they have a different mass. Yeah? The electron has a mass of 1 and proton of 1800, So when you shoot them through a magnetic field, one will be deviated very, very strong and the other will just go straight forward. Okay, so, but now imagine you have two magnets that are flat, two flat magnets, and you place them on a table and you push them together and they repel each other when they have the same orientation, the North Pole upside and a South Pole downside, or vice versa. The moment when they flip, they attract each other's. And now you can answer, you can ask the question, is it that, so this experiment can only be done when there is gravitation. So when they are flat on a table in space, it will not work. In space, yeah, they just turn
right and connect
to the right, turn around, and then they crash together, yeah, in space. So it is that the gravitational force allows you to see a monopole.
Well, you could build, I mean, you could build barriers in zero gravity that would stop them from, because what you're saying is the friction on the table is greater than the magnetic attraction or repulsion. So you can have them in isolation until they get too close, and then they overcome friction and snap together.
The leverage of the shape.
It's not, it is, first, it is not the friction, it is that you have to lift one of the magnets in the gravitational field. So you have to add some additional energy and then it flips around. Yeah, it's not friction. It just, so yes, so gravitation is just the most simple kind to produce such a force. So this is called the potential, yeah? So
now,
to have a mechanic,
that's in the size of the flat magnets,
right?
But
right.
To a point where you can't, where the gravitational force can't affect.
Right, but you can also have two plastic sheets with a little space in between, and you can move. But this just introduce another potential. Yeah, to turn around, you need some energy you don't have.
Okay.
If you don't have the energy to turn it around, then you will see monopoles. Otherwise, you will see a dipole. And the question is there another dimension in the three-dimensional space so that we cannot flip around the electron to become a proton?
Well, they still have mass differences anyway, right?
Yes, but energy can be transferred to mass. So this flipping may produce the mass needed. For some reason, we can produce energy from electrons and positrons. So we can disintegrate matter to energy, and we can create matter from energy. Those experiments happen in high energy physics every day. Yeah? So it is just a model. So what we see is always the way how we think. And in the past, this thinking has changed. And hopefully in the future also it will change. So look, you have the imaginary numbers. And this is because you see the natural numbers as natural, and the imaginary numbers, they are only imagined. But then you realize, okay, natural numbers also are imaginary.
Oh yeah, I see. Yeah, the imaginary number is a way to break out of one dimension.
Right.
But really, there's nothing imaginary. I don't know why they called it imaginary. That were like throws everybody for a loop. It's a way to qualify 2 dimensions.
Right. It's another type of object. A complex number is a mathematical object that comes from the need that was invented or discovered for the need to find a square root of negative number. And then they discovered this. And there are so many math videos around now that I could never imagine to be interested in this stuff before. So it's only in my last days that I'm interested in those things. And now I realized if you multiply 2 complex numbers, it means you can represent a complex number by length and angle. And to multiply 2 numbers is multiplying length and adding the angle.
Oh, right, right.
So if you only take those numbers that have a length of 1 and a different angle, it's a circle. And now multiplying 2 of those numbers only means that you add the angle. And we know this from logarithm. So if we multiply numbers, we take the log of the number and then we add it and we go back to find the product. And logarithm and exponential, they are the inverse operations. But complex numbers can be represented as an exponential. E power I omega f phi p I phi. So yeah. So everything in math is linked, and that's fantastic. It's really
Yeah, this is the sort of thing that that makes your brain go like fuzzy. It's like, wow, it's everything kind of connects into the other thing. They're all the same things from a different angle.
Yeah, we're trapped. I think being in a 3D...
I mean, the funny thing about the angles with the complex numbers is that if you go into 3D, that's actually the only way to do it properly, is to use something called a quaternion, which doesn't just have one imaginary number. You get 3 imaginary numbers, I, J, and K.
Yeah. Yeah.
And that doesn't answer the question what the square root of -1 is, because really it could go in any direction, right? But because we're now in 3D. But if you take the square of any of the imaginary numbers, it's -1. And if you multiply them all together, it's also -1. But if the order is wrong, then it's something else.
Yeah.
And that's actually the only way to model things that are like spinning in 3 dimensions in a way that you can actually compose multiple rotations onto each other.
Yeah. Yeah. But if you look to the history of the quaternions, you will find it comes from Hamilton. And the point is, if you look to a quaternion, you have 4 components. One component is a real number, and the 3 others are imaginary. Yeah?
Mm-hmm.
So now, these 3 others can be represented as a vector. And we know that the cross product of 2 vectors gives you another vector perpendicular to the 2 others. Yeah?
Yep.
Yeah. So, and we know that the inner product of 2 vectors gives you a scalar.
Yep, we also know that.
And now you can say, okay, imagine the quaternion is a scalar. So a scalar product, an inner product, and a cross product combined. Right. And then you are in the field of geometric algebra. And that was invented also at Hamilton's time by two persons, or it was in principle found by two persons. One is Grassmann, and the other one is not Gibbs, Clifford. So therefore, it's called Clifford algebra, or geometric algebra, or Grassmann algebra. And the point is, Grassmann was not a mathematician, but he was busy translating Sanskrit. And as he was deep in languages, he thought, okay, let me invent some mathematical language, some language of math. And so he founded the basis of geometric algebra, but he was forgotten until now. And now it's a hot item in math, geometric algebra. So it's so funny, you know.
It is, yeah. This knowledge is increasing.
Yeah.
This is like, you know, imagine people like two-dimensional creatures living on a piece of paper. And then they're trying to contemplate. Like, there's got to be something else going on here. I can't figure out what it is. But what they're trying to contemplate is the third dimension, but they have no reference for it. Yet, but they could maybe still come up with some kind of representation in something like math to do that. But that's kind of what we are doing, living in this three-dimensionally constrained. What to us is only 3 dimensions. But a fourth dimensional person will look at us and go, look at these guys struggling with these most basic principles.
Yeah, well, it's like the sort of thing where like 4 dimensions would be like really different. Like you see with the rotation thing, in 2 dimensions, rotation is simple. There's only one axis that you can rotate around that doesn't even really exist. It's that z-axis that doesn't exist in the 2D space. Whereas in 3D, you're rotating around an axis that also exists as a direction that you can go.
It gets too hard to even contemplate. We don't have the facility.
Like there's something even different that happens in 4 dimensions, which I don't even understand. But I know that it needs like 8 components or something like that.
That's the standard model is that there are about 8 dimensions, but they are not sure. So it's not completely understood to now. But anyway, what this example with the flipping magnet shows is that there has to be an external gradient field that prevents things just from flipping. And we see that this needs very high energy. So, and if this needs very high energy and the space is not completely filled with energy, but only in small points, it means those high dimensions cannot exist in a large scale. They only can exist in a very small scale. And that is where we find them, in the nuclear. In the nuclear, there we find those dimensions. They have no influence to our environment. So the wormholes are not feasible in practice because the energy needed to create a wormhole is more than the energy is available, and we are limited to this amount of energy that is with us. And 300 centigrade, that is not a lot of energy. So therefore, the nuclear forces should be kept in the nuclei and not be used for humans. So we have this, that is my credo. We have this perfect fusion reactor 8 light minutes away from us. We get an energy source of 6,000 degree temperature, which hardly is to create on Earth. We only have to collect it. And when there will be peace, it will not be a problem to have enough aluminum around the world as a belt to bring energy to any place you can imagine. I think we have 40,000 kilometers of railway railways in Germany, 40,000 kilometers. So that is just the circumference of the Earth. Yeah, and it is affordable to have aluminum, aluminum conductor to transfer energy around the world. And as we know, the sun shines always
somewhere,
everywhere. Yeah, that is this information that the sun shines always is so fundamental that you can have a Riviera in Gaza or a Riviera in Florida, and you will always be in the sun. Yeah.
You're saying build a reflector to get rid of night? Is that what you're saying?
No, not reflectors, but just
something like solar panels.
A cable, just a cable, a conductor. So you say, okay, you cannot make a copper wire around the world because there's not enough copper and it is extremely expensive. Yeah, let me say, yeah.
Yeah.
So, but the resistance of aluminum is only twice the resistance of copper. So with the same weight, you can deliver more electric energy. And it is cheap.
So you're saying copper weighs more than twice what aluminum weighs?
Yes. Yes.
Okay, and so you actually get better like conduction economy through aluminum than you do copper.
Right.
Okay,
and
maybe that's like they're using aluminum wiring in heavy power infrastructure these days. That must be why they're doing it.
Sure, it's cheaper, it's lighter. Yeah.
Yeah.
And
I never understood that. So yeah, you just make the conductor bigger crosswise, and you have enough cross area that it's over twice copper, yet it still weighs less. Well, not the cross area, not the radius, but the area.
Yeah, yeah.
So that's why I always think, why are they using aluminum? It's not like, are they too cheap to use copper? But there's actually a value reason behind using aluminum.
Right, right. And not only it's to carry the weight of copper, you need steel inlines. Yeah, even in the aluminum wires, you have an inline of steel. Yeah.
But what are you thinking would be okay, so you have a band of aluminum or copper going all the way around the Earth.
Yeah.
To what end? What does it do?
It just brings the energy to the place where it is needed.
Oh, okay. And the energy is coming from the sun.
The energy comes from the sun. So you say, okay, the sun the sun shines only 8 hours a day or 10 hours a day, and it doesn't shine in winter, and therefore we need nuclear power. Yeah. And we do not care about the waste because that's not our business. Yeah. But I'll bring them up, but where they come down, that's not my department, says Werner von Braun. So
there's
old
been
song.
some very interesting research on how to actually like long-term store the nuclear waste, like in 10,000 years or something. That stuff's still dangerous. Maybe not 10,000, maybe like just 1,000, but that stuff's still dangerous. So like, how do you make like a message that people that may speak a completely different language and don't even remember you existed can actually read that message and notice, hey, don't like start digging here. This stuff will super duper mega kill you.
Yeah.
Yeah. It's called nuclear semiotics if you've ever want to look that up. And there's a very interesting phrases. There's something, nothing of value is commemorated here. Do not cherish this place or something like that. Like these very interesting, ominous messages that they came up with.
Needs to have, there's anti-value here.
What's
okay. I gotta get going, you guys, because my wife and I are supposed to be somewhere 20 minutes away in 45 minutes, and I'm supposed to make a salad to take there. I don't even know if I have the ingredients.
That's the funny message. This place is a message and part of a system of messages.
I also
pay attention to it.
I also have to
Sending
say
this
what happened
message was important to us. We considered ourselves to be a powerful culture. This place is not a place of honor. No highly esteemed deed is commemorated here. Nothing valued is here. What is here was dangerous and repulsive to us. This message is a warning about danger. The danger is in a particular location. It increases towards a center. The center of the danger is here, of a particular size and shape, and below us. The danger is still present in your time as it was in ours. The danger is to the body, and it can kill. The form of the danger is an emanation of energy. The danger is unleashed only if you substantially disturb this place physically. This place is best shunned and left uninhabited. Imagine you're like some guy after like the Third World War, like wipes out the civilization, and you like go around in the forest, you like find stuff like that.
Very ominous. Yeah, that's the word. There was a really good, I think Showtime made it. It was called Chernobyl. It was like kind of a dramatization of the Chernobyl meltdown in '86.
Yeah.
It was really well done. I was surprised. It was really good to watch. It was like a 5-hour, I think there were like 3 or 5 parts, but it was like 5 or 6 hours altogether. But I really enjoyed it.
Yeah.
Okay, well, guys, thank you all for coming today. And we got to go, but we'll see you again in a month, hopefully.
Yeah.
Oh,
Okay.
I didn't even get to show the improved teapot.
We'll hold it for next time.
Next time.
Thank you.
Maybe it will be even better.
All right, guys, take care. Talk to you later.
Thanks a lot.
Bye.
Bye-bye.
Bye.